the starting systems now, and I'll pre-warn you. A lot of this goes probably a little bit more in depth than it needs to, so just be aware. But I'm going to tie it together with this is what's nice to know, and this is what is needed to know. So if it's a nice to know, and you know it, that's cool. You could be a little bit extra prepared or a little bit especially knowledgeable. But at a minimum, if you get the need to know, you'll be able to diagnose the car that won't start. That's really my ultimate goal. So jump right in there. You guys should know a little bit about starting systems because you get in your car and you turn the key and it just does the sha na 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 and then fires up. But if we were to go way back in time, did you know the original cars did not have a starter? Anybody have any idea how we started those? Yeah, the crank. Isn't that crazy? So yeah, you'd say like, oh, I would like to, go for a ride and to be honest, a lot of times it wasn't even the vehicle owners who started the car. They would have like a chauffeur mechanic who would go out there and, you know, put the crank handle through the grill onto the crankshaft and actually, hand turn it over. And there was quite a few people who were injured. I don't know about killed, but I definitely know there were some broken arms. So that was how we would do it. So if you really think about what the purpose of the starter is, it's it's to start the car, but actually what it really is to provide the rotation needed to build compression to initiate the combustion process. And then once you initiate the combustion process, we've got that compression, that air that's been drawn in, we got that fuel that's been sprayed, and then we've got the spark plug that ignites it all. Once we get all that, then that combustion, the flame, if you will, the firing, will push the piston down, and then it gives that crankshaft a lot of, rotational inertia, and that'll keep it going. The challenge is when it's not moving yet, we got to get it moving. So how we get it moving back in the day was literally this, right? The starter, however, it doesn't provide the fuel, it doesn't provide the spark, it doesn't exactly provide the compression, right? So if a car doesn't start, a lot of times people will think, oh, it's the starter because it does not start. They have the same name. So when we focus on this, just remember the starting system, all it really does is provide that initial rotation. That's it. So really, we're just focusing on the chauffeur mechanic doing the crank. We fired that guy. And instead, we hired this one, this non-gender specified individual right here. This thing does what the chauffeur mechanic did with the crank, and that's really it. It's crazy as it sounds. Now, let's say part of the reason that they'd have the chauffeur mechanic do it and not just the homeowner or the vehicle owner or whatever is because there's a little bit of things to watch out for. So these are a manual transmission vehicles back in the day, right? So if it's like a Ford Model A, what do you think we need to do to ensure on a manual transmission vehicle before we crank it over by hand? Yeah, if it's not in neutral and you crank it by hand and you're going to try to crank it and it's going to start rolling toward you, right? If it's in forward gear. If it's in reverse, interestingly enough, it'd start backing up. But if for some reason they were unable to tell that it was in gear and they were to get it cranking fast enough to have it start, it'd run them right over, right? So there were no safety mechanisms back in the day. So on a newer car, when you get in, of course, you got to put it in neutral, but we've added a lot of things. So if it's an automatic, there's going to be a switch that's going to tell if it's in park or neutral to make sure we're not cranking it in gear. If it's a manual, there's actually no switch typically for the shifter, but there is a switch down on the clutch pedal to make sure your clutch pedal's down. And that's why in a manual, when you go to start it, it won't start unless you depress the clutch pedal. So these are safety mechanisms that we've added. And then, of course, additionally, if you think about like what I was saying a little earlier, the battery, the starting and the charging, they go together. Well, this just provides the rotation. This does not harness energy or store energy. It just, all this does essentially is it takes electrical energy and it converts the electrical energy into mechanical motion. That's it. So if you're battery is discharged, this does you no good. If your battery is kind of like surface charged, like a shallow puddle, but it has no depth, it doesn't have any cold cranking amps left, it's probably not going to turn this with enough force to actually crank the engine over, build compression, and start it. See what I'm saying? So the starting system and the battery, there's a lot of overlap there. So before we start, I'll tell you an embarrassing truth. After graduation, I think it was actually when I was still in community college, but towards the end or maybe after, um, you know what everybody wants, right? Is side jobs. You all want to do side jobs and build mega cash, right? Because you can go work a job at $20 an hour, or you could price a side job and pay yourself, I don't know, what do you want to pay yourself per hour if it's your side job mobile mechanic business? Shoot a number. It's your business. You don't have to negotiate. You don't have a boss. You are the. How much? How about 50? All right, settle for that. All right, so it's similar to me. Like, yeah, I want to do a side hustle, and that way I could build more per hour. So I had somebody say, hey, my Dodge Neon, so this is showing it's a little while ago, won't start. And I was sort of like, oh, okay, well, what sound does it make? And she just said, I get in and it goes click. And I'm like, oh, all right. It sounds like it could be the battery. So I went over, and the way that I tested the battery, remember, when I'm in the shop has special tools, right? Battery testers and full battery starting charging system testers and all that type of stuff. What I have was my DMM and hand tools. That's what I have in my travel kit. So I go over, I'm like, I think it's probably gonna be the battery. So the thing that I do is I put the windows up and down, and the windows move. So I'm like, was the battery dead if the windows move? I turn the lights on and the lights go on. I noticed they were a little bit slow, but like they moved. So that tells me that the battery is good. Then I went to the starter, and I did know enough to really diagnose this, but I just wasn't understanding the tight relationship between the battery and the starter. And I checked. This had 12 volts or so. And then I checked to make sure it was getting power when you turn the key, which is like the main step in diagnosis. And it was. And the starter actually went click, kind of like, it's trying to do something. And I'm like, oh, that starter must be like just bad. I don't know, seized up or something, and it wouldn't really crank it. So I go to get a starter, and the auto parts store's like, no, we don't stock that one. It's special order or whatever. I end up having to go to the dealer to get it. It was like $350. Kind of a tougher one to do. I put it in. Where do you think this story's going? It didn't fix it. And I was like, oh no, like how can this be? I got a bad starter out of the box. So the customer called out for a bad starter. I put a new starter in, and apparently that starter must be bad. Do you think that's likely? I don't think so either. So I had to really rethink some things. And I was like, hmm, well, what else could it be? Could it be voltage drop in the cable? Could it be maybe a bad contactor in the relay? Could it be the park neutral switch? Could it be all these different things? And I got myself really, worked up. And do you want to know what it ended up being? The battery, good guess on the loose connections. The battery had low cold cranking amps like a sulfated battery. So it probably didn't have a whole lot of surface area on the plates. It had enough surface area to run the lights and windows. But when you go to start this starter, when you go to crank this thing's going to draw like 150 amps. It couldn't provide all that. So it would just kind of like click and try to turn the engine against compression, and it wouldn't really do it. The way that I diagnosed it was simple, because again, mobile mechanic side business. I don't want no boss. I don't need no boss trying to make a hustle without a battery tester and whatnot. I jumped it. I literally just hooked up my truck jumper cables to her car jumper cables, and it fired right up. And I was like, oh no, how do I explain this? So I had to tell her, like, hey, it seemed like the starter was bad, but it turns out it's the battery. And the conversation went better than expected, because she said, no, it can't be the battery. The lights turn on. And I was like, well, that's what I thought. But it's definitely your battery, because if I jump it with my battery, it functions. So we got to get a battery. So just in full transparency, it's not as simple as it may seem. And now having a lot more experience and a lot more training, but definitely a lot more experience, I could have diagnosed that in three different ways that would have eliminated that misdiagnosis and having to explain the customer. I didn't charge labor for replacing the starter. It's not really right. I misdiagnosed it. She did pay for the starter. I think actually she asked if I could take it back out, and I called the dealership, and they're like, "No, we don't take back used parts. Like that's on you." Now you can see why parts stores and whatnot say we don't. It's not Costco. Like you don't get to take it and try it out and bring it back a week later. Like they're gonna say no to. Was it installed? Yes, and we're not taking it back. Kind of makes sense. You could lie, but that's all. That's on you. I'm out. All right. So from there, now we know the new system is going to actually simply provide a way for this to crank the engine over, and we're going to send power to this from the battery. But there's got to be a whole system in place to make sure that, it's safe to control how it works, to make sure it doesn't damage itself or hurt anybody. Right. So if we think about it like this, it's a method of rotating or cranking the vehicle's internal combustion engine to begin the combustion cycle. That's what I was saying against the compression, right? So it's got the battery, of course, high and low voltage, high and low amperage wires, not voltage. It's all the 12-volt system. It's not a big deal. But when we say low amps and high amps, essentially what we mean is like, well, I got the starter right here. The high amp wire, what size do you think that's going to be? Big battery cable goes here. You ever notice there's a small wire that goes right next to it? That'd be the low amp one. So the low amp wire that's small essentially controls the big amp wire that's big. Kind of makes sense. So a lot of times, mostly what we're testing is going to be the small amp wiring, low amp wiring, because that's the one that has to go through the ignition switch and the park neutral switch, neutral safety, and or the clutch switch if it's a manual. And sometimes that gets its signal from an ECM. And so like the control side of that relay is there's a lot more going on there. The big amp side, that's the big cable. We we still need to do some testing on that, but like it's a big old wire that's not typically where the failure point occurs. There's not really that much going on. It goes from the battery, sometimes through a fuse, and sometimes there is no fuse on that wire. Sometimes there's a fusible link, and it just goes directly to the starter terminal. And so, like to test, it's not a real hard thing. Um, the problem is when you go to test that, if you test it with like key on or key off or not cranking, it's generally going to pass. It's sort of like you're not putting it to the test. To really test the high amp size, you probably have to have it cranking. It's sort of like testing those switches when we were working on the boards. You could test a switch by testing ohms or even volts, but like by the time you turn it on and make that switch work with a bunch of bulbs on, you notice all of a sudden you got a big voltage drop. To really test the high amp side, you probably need to really do it while it's cranking over to see if that cable has a voltage drop. It's most likely not going to show a voltage drop when you're just testing it, not cranking. Cool. So what happens when you go to crank it? Well, more than you need to know right now, but this terminal right here has power all the time. When you go to crank it, the little wire goes through all of its circuits and its neutral safety switch and its ignition switch and all that type of stuff. When you go to crank it, power comes into the little terminal. Like on this one, it's just a little spade. When the small wire gets power, it actually jumps this solenoid closed, click, and then the big battery cable is actually connected to the starter motor and it goes zin, 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 zin. Makes sense? So that's really what's going on there. And I'm going to show you that in a couple diagrams. But once it gets small power, it sends the big power. And that's going to cause that, sometimes you'll call it the Bendix or the starter gear, to jump out and spin. Zing, 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 zing. That's going to engage the flex plate or the flywheel. Flex plate is for an automatic transmission. Flywheel is for a manual. Sometimes we just say flywheel when we should say flex plate. But in this case, it doesn't really matter whichever it is, a flywheel or flex plate. has a ring gear on the outside of it, and that starter Bendix gear is going to engage that ring gear and turn the flywheel or the flex plate, which is bolted to the crankshaft. So that's how it works. Now, I did have one time that was appeared to be a crank no start. So let's just explain the difference. A no crank no start is a click or nothing. You don't hear the engine cranking, okay? That's a no crank. If, in other words, if the starter doesn't move, how would you say? No marcha, right? If the starter doesn't move, that's a no crank. That's a very different diagnosis than a crank but no start. So if you jump in the car and you indefinitely and it never starts, that's not a problem with the starter, right? That's not a problem with the starting system. That's a cranks but won't start. That's a crank no start. So now if I say no crank, you know it's no starter engagement. And I say a crank no start, I'm not real worried about the starter because the starter's cranking the engine over. Maybe the engine doesn't have fuel. Maybe the engine doesn't have spark. Maybe the engine's not making compression, right? So that's where your mind goes. Instantly, if it's a crank no start, it's no longer A6 material. It goes into A8 material. That's engine performance. That's fuel pumps and ignition coils and even it could technically be A1 stuff, which would be engine mechanical things like timing belts and chains and these things. Right? So this one was a crank no start. You could hear the starter moving. Starter, shing, 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 shing. It sounded a little weird though, I'll admit. But when my friend was telling me, I think it's the starter, I'm like, no, it's not the start. You can hear the starter turning. Like it's cranking over, but it won't start. I think it's going to be more like fuel or spark or something. And this was, again, I have a lot of these stories from when I first got out of school because I knew material, but I couldn't always apply it because I didn't have the experience yet. So that's just everybody has to know. You could study this up and down and memorize everything, but you're still going to get confused because you don't have that experience developed yet, right? It's the same as whatever. You pick a sport or activity. You could watch all the replays. You could do the chalk talk. You can study the plays. You can watch the technique of how they ride the bike or whatever, but like until you get your butt out there and do it, like for a lot of hours, you're not really going to be that good, right? So with this one, crank no start, I'm thinking fuel and spark and whatever. And after being confused and trying to pursue it, all of a sudden we realize when my friend cranks it, it's an old S10. I look at the belt and the belt's not turning. So I'm like, why? If you hear the starter, shing, 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 why is the belt not turning? And then we got very confused. And then we ended up having to like pull a cover off the back and you could see the starter jump out. We started to think maybe the starter was just spinning, but it didn't pop out to engage the flywheel. That was a pretty cool idea. But then when we pulled the cover off, we looked, right? It pops out, it engages the flywheel, and it appears the flywheel is turning. This is on a manual. But then I look at the front and the engine's not actually turning, like the belts and stuff aren't turning. It was crazy. The backstory on it was the clutch was slipping. The clutch was slipping so bad it stopped moving. What was really crazy on that one was it actually was a starting problem. It was cranking, but it wasn't starting, but in a way it wasn't really cranking. The starter was turning, it was engaging the flywheel, but it got so hot it actually broke the ring gear off of the flywheel, and it was just spinning the teeth on the ring gear, but it wasn't spinning the whole actual flywheel. And so that one was a fun memory. It was really mainly because he overheated the clutch so bad, it actually allowed the ring gear to warp and like separate from the flywheel. It's a very confusing one. Kind of my point being, the way that you do diagnosis is you don't just like know, oh, if it cranks, if it doesn't crank, it's the starter, but if it does crank, it's this. Like you got to actually get down there and look at it and really understand it. So we're going to target how to understand it. So when you get these cars, you hopefully don't get as confused as me because I really hope you all surpass me in your understanding. That's my goal. Now I can't lose. So if you pass me, I win. And if you don't pass me, I still win. Very good. Here we go. Here's what happens with that starter motor. When we send the big power to the starter, you can see this is going to be positive, right? This positive is going to essentially go through this magnetic loop and then come back more as a negative right here and go back to the battery. And that's it. And we're going to look at this in a few different ways, but if you think of the starter as a load, this right here is going to be a resistor because it's a winding. It's got a lot of length of wire. So the 12 volts should go into the starter. All the 12 volts should be dropped in the starter, and then it should come back with about 0 volts. So if we had a problem on this, and let's say this little switch right here was dropping voltage, if that switch is dropping 2 volts, that means this starter is only going to get 10 volts. What do you think the concern is going to be? But what would be specific? If it's supposed to get 12 and only gets 10, if it was a light bulb, what would happen? Dim. Exact. So it might turn kind of, but it might not turn that fast. It might turn slow. Exactly. So this whole time when we're talking about the starter, remember, it is a load in the system. So all the things you've learned still apply. If it's getting voltage drop out here, if it's getting excessive voltage drop on the negative terminal, if it's getting excessive voltage drop on the positive terminal, if the battery is not fully charged, that's all going to have an effect on the way that the starter turns, just like it would on the brightness of the bulb. Okay, makes sense? But if you look at this, yeah, we're going to say we're going to send 12 volts. But the other thing you have to understand is when you're actually cranking it, this draws so many amps, 150, 200, 250 amps. Your battery voltage is going to go down. Normal, it's just the way it is. Like you're drawing so much from the battery. Your 12.6 volt battery during cranking is probably going to be more like 10 point something. That's normal. If you ever were to go out and start it and be like, oh my gosh, when I crank it, the battery drops down to 10 volts, there's something wrong. No, they're all going to do that. It's just discharging so much electricity, it's going to drop, right? So just, we say 12, and it is 12, but not during cranking, it isn't. Okay, it's your first lesson. And then we're assuming that this battery has enough plate surface area and sufficient level of charge to be able to deliver the amount of amps that we need. Right, so that's why batteries and starting kind of go together, and that's why I got confused and I had to not get paid on that labor, on that misdiagnosis that I did. Cool. Now from here, we're gonna get a little bit more into this in detail, but just so you know, the way that the starter works is electromagnetism. So if we have a current flowing through this loop, let's just say that's a conductor loop, it's going to generate a magnetic field. That magnetic field is going to interact with this right here, which is a permanent magnet. You see that's a south magnet, and this is a north magnet, right? So it has the ability to either attract, like right now, if this loop is attracted, it's going to pull down right to the middle of the south, right? Because opposites attract. So we're going to make them kind of like an opposite. That's the way I would think about it. Then what do you think has to happen? If it attracts it down to the S, don't we kind of need it to like repel? To keep moving, right? So that's what we're going to do. We're going to actually, this south magnet and this north magnet, those don't switch. But what we'll do, if you see this thing is a commutator, it looks like it's split in half. By the time it gets down to where it's at that S, this little thing, which is called a brush, is going to flip over to the other side of the commutator, and electricity is not going to go this way. It's going to make it go the other way, which is then going to repel from that south magnet. All right. Sounds a little bit crazy, but when we show you a few different pictures, I think we're going to slowly build up to this. All that we're really doing is we're using current flow to generate a magnetic field, and that magnetic field, we can have it either attract or repel. And so the switching between, flowing this way and flowing this way, all that switching occurs right out here with this mechanical thing called a commutator. So this is an image that's simplified. We wouldn't just have one switching and one loop. We're going to have a whole bunch of loops. All right. Now, We could, sometimes I go a little bit overkill on the function of motor and how to tell which way it's going to magnetize, which way it's going. I think it's called like Fleming's left-hand rule. And the last time I taught this, we had an electrical engineer in the class, and he was like unbelievable, his depth of knowledge on some of this. He could look at it and be like, oh, yeah, immediately looking at it, know which way it was going to turn, how it was going to turn. I mean, just incredible. And I liked it, was very fun to talk with him. However, I did a reassessment and I thought, my main goal for you, two goals. One, be able to diagnose and fix the car. And two, prepare you for the test that I think is going to help you the most, which would be the ASE. So, probably shaving an hour worth of discussion about the details of how the motor works and how the electromagnetism works is probably going to focus your energy more where it needs to be rather than like you could go way off in the weeds on different types of motors. And we get into all sorts of brushless and whatnot. But if you just look at this, these brushes carry the current from, let's say, the positive, and they make a connection here. And this commutator makes a connection to the actual winding. So if you think about it, the motor is spinning. You can't wire to it because it's going to tangle the wire up, right? So we got to have a thing where we can connect to it and slide across it while it's spinning. Does that make sense? You can't hard wire to it because it'll just spin in a circle and tangle the wire up. That's essentially what's happening here. We send positive into a brush, and then the brush is going to ride on a commutator. Sometimes they'll have like a slip ring or these different versions of the motor, but just understand this thing is fixed and it's pressed up against the commutator, which is spinning. So we have an electrical connection made on a fixed brush that's riding up against this commutator. And that's a point of wear. So, you know, that brush wears down a little bit, a little bit, a little bit, a little bit. So all starters have a life expectancy. They're not going to last forever. It's just the way it is. So when I went to do my kind of restoration on my Hummer, La Toxica, I thought about it and I'm like, I've been through a lot of stuff with my wife. She hates that truck because it's broken down and overheated and this. I've had it a long time, okay? It's to be expected. But when I thought about how can I make it as reliable as possible, when the starter's original, you know what I do know? There's definitely going to be a substantial amount of wear on the brushes because it's 15-year-old starter. How much life remains? I really don't know. So my logic was, let me put a new starter in there. Now you got an option. You can do a refurbished, like a reman starter. That's who remanded it? I don't know. They sent it somewhere and someone replaced something and then they spray painted it, put a sticker on it. So like, is that more reliable? And it should have new brushes, but is that more reliable than a used OEM one? Maybe, possibly, but I'm not sure. So I didn't opt for that. I went for like the $350 OEM, not remand, new starter. If it's brand new, I'm thinking like all these components are going to be really fresh, and that's going to minimize my chances of having it not start somewhere and having her just be like, whatever, I'm done. I'm never riding in this truck again. Because that's part of the reason I restored it was like, I'm going to fix everything. It'll be just as reliable as brand new, which wasn't totally true. But then again, brand new cars break down too. There could be any number of defects in this motor, but the main wear item is right there, the brush. The brush is dragging across that surface and it wears and it wears and it wears. And eventually, because it's being pushed by a spring, it tends to lose some tension. Eventually, it doesn't start. So what we do, like I talked her through on her dad's old Cherokee that didn't start, I was like, hey, go under there and bang on the starter. Anybody ever had to do that? That's how I know you guys are. We both driven some hoopty stuff. Isn't that a nice way to put it? Hoopty. That's not offensive. Yeah, well, I think it might have been. If you know about banging on the starter, it was a hoopty. I'm just letting you know. Right. So if this brush wears, eventually it's probably not going to want to start. And then you bang it on it sometimes jars the brush and helps make another contact and it starts again. How much it may start one time, it may start 50 times, but eventually, guess what? It's probably not going to start. You know that, right? So when her dad called me and said, hey, the Jeep doesn't start, I'm like, let me stop by on the way home from work. with a little more experience. I had a lot on the line at that point. I'm like, I can't misdiagnose this. He'll he'll ban me from the house and they'll break my heart. So I'm like, I have to diagnose this right. But the diagnosis is easy. Check the voltage at the starter. Big battery terminal's good. Check the voltage at the little wire. I said, hey, can you hold the key? Can you crank it? When he cranked it, boom, I got power there. Doesn't start. Didn't even really make a noise. Starter's no good. No big deal. However, when I said it needs a starter, I'll get it and I'll fix it this weekend. What my wife heard was, you fixed it? Because while he was holding the key, I was like, let me show you. Bang, bang. And I banged on it and it fired right up. So what she heard is not what I said. So she took it to no place other than Walmart. And guess what happened when she came back outside? It didn't start, and it was during a snowstorm, and it was really nasty outside, and it was dark out. And so when she called, and I'm at work, and she's saying, hey, the Jeep didn't start. And I'm like, yeah, I would assume that. It's probably got a brush that's sticking, and like it really needs a new starter, or it needs a reman starter, because we don't commonly go in and replace these brushes, right? So don't use it. Well, the problem is I'm at Walmart. I'm like, oh my gosh, did you not hear a word that I said? I said, don't use it until the weekend when I fix the starter. But she used it. So I said, it's like this. You have a spare tire change, like a tire iron down there. If you use that and you go find the starter and you tap on it, it'll start. And what do you think her response was? What's a starter? And I'm like, okay. Go under the car and look up and look for a thing that looks like a soda can. It's going to look like a soda can. And then call me back. And then sure enough, she calls me back in like 15 minutes. She's like, I got it. And I'm like, no way. I thought there was no way she was going to get that thing running. No chance. But I told her. Then she told me the truth. While she was under there, another lady's walking by and she sees some feet sticking out like this. She says, and they're, female style boots. So she's like, hey, what are you doing under there? And she's like, I'm looking for a starter. And the lady's like, oh, that happened to my car. I know what that is. And they're both laying under there in the snowstorm together, and they find the thing and they bang on it and go to start it and it starts. Okay. So it's a fun story, but the good thing is, depending on what tools are available to you, if it appears to be a starter and you think it could be due to worn brushes, or even if you had one of these conductor loops burned up, sometimes the diagnosis is as simple as banging on it a little bit. And if all of a sudden it starts, I'm not super worried about voltage dropping the cable and checking the relay and checking the neutral safety switch and checking the clutch switch and checking the ignition switch. Like when I banged on the starter and it worked, it tells me the problem is here somewhere. So my favorite thing about this little slide right here is you can visualize a little bit about what's happening in that starter motor. I would use a rock. I I would use I would try, I don't know, this is probably a little too soft. You just need something that's going to jar it. All right, now I have to give some disclaimers. If you buy a reman starter, it says right on there, do not hammer on the starter, because if you damage the starter, it can no longer be remanned. And additionally, I have to be honest, on the newer style starters that have the permanent magnets, a lot of times banging on the case could actually hit and crack that magnet. So if you bang on it and crack a magnet, well, I probably still would, to be honest with you, because it was like a Hail Mary play of a plan to get the car going anyway, and you needed a starter, and now you need a starter, so would you lose? But technically, to the reman people, they're like, all it needed was brushes, but now it needs brushes and a magnet because you banged on the thing and dented it and cracked the magnet. Kind of makes sense? So everything I'm telling you is not really the professional way. It's more like what you do if you're in Walmart in the snowstorm on your back. That's what you're going to do. And it might work. Fun. So as we continue, we could go really in detail on the inner workings of the motor, but the reason I tell you that story is because that's about the extent of understanding exactly how the motor works. That's going to be helpful. Cool. So if the car came in, I should really be using my meter to do all the diagnosis, but like And I will if it's a customer car because I need to document it properly. But if it's somebody on the side of the road and in the parking lot and whatever, and I don't have all the tools, like sometimes just banging on the starter will make it work. And now you understand exactly why. The brushes tend to stick as they get worn, right? And they'll stick and they won't make a good connection. So now if we look at this, this is similar to the other one. When we send 12 volts up to this commutator, you'll notice right now that brush, because this commutator is spinning clockwise, that brush is about to jump over to the other side, which is going to make it flow the opposite direction. If it flows this direction, it was attracting. If it switches direction, it's going to be repelling, if that makes sense. So if we were to look at this upper one, right now, I would say it was repelling. And then in a second, when it flips, it's going to actually start being attracted. So it's just going to flip back and forth between attract, repel, attract, repel, attract, repel, attract, repel. The main takeaway is going to be we don't test the attract, repel. We don't switch what we call the commutating or the switching. To check that, you got to take the starter all apart. All we're really going to do is we're going to test up to the point where it enters the starter. That point is right here. So if we test there and it's getting a good 12 volts or whatever, then we trust the rest of the starter to do its job with the switching, commutation, and all that type of stuff. We just make sure it gets it there. Now, let's say you go to test it and there's no 12 volts there. Well, obviously the starter is not going to work. It's just not going to work. But if you test and you got good power there and the starter doesn't work, what do you know? You know that it's inside. And the reason I'm cutting some of the technical details off of, inner starter function is, does anybody here plan to rebuild this? Because we used to, our ancestors, our mechanic ancestors didn't replace starters. They'd take the starter, disassemble it, replace brushes, test things, replace bearings, whatever they would do, they'd fix it. So if you're in a place where you're gonna diagnose it and then reman your own starter, you need to know more. But I'm gonna say the percentage of technicians that are gonna reman their own starter, less than 1%, probably less than 0.5%. So we're just gonna focus on the diagnosis. And once you know it's the starter, what do? You go get a new one or a reman. And somebody else is taking care of what's inside the case. So here you go. Looking at this one right here, a lot of times doing a starter on a front wheel drive involves like, pulling an air box or pulling covers. Sometimes they're on the bottom, sometimes they're on the top. But if you're going to do the diagnosis, mainly what we're trying to do is make sure that we've got power going to the right place. That's essentially that's like the basic diagnosis, right? So in this next slide, I want to show you exactly what points to check. But if you understand you're checking in this type of area, it can actually be really hard to get down in there and get your meter in those spots. But what are you going to do? Sometimes it is kind of difficult. And if you're testing right here, it's helpful to have a person inside the car to turn the key. But what if you're trying to do it alone? That's when we might go back to the DMM functions. And you could do like min-max. Do you remember that feature? If you put it on min-max and you're expecting 12 volts, and you have it probed nicely, and you go in the car and you hit crank, and then you can come back out and you can say, did it have 12 volts? Did it store the max voltage of 12.6 or whatever the number is? Probably less if you're cranking, probably 10 point something. Cool. So here's what we could test. All right. This is your first basic starter diagram. And what I'm going to do is let's go ahead and we'll trace this. It won't be a very hard one to trace. If I go right here, we'll do a highlighter. Let's do red. We agree this is the positive cable, right? That red is not particularly red on this screen. All right. Power goes right there. When does it go right there? That, by the way, is this terminal right here. When is 12 volts making it to the big terminal on the starter? Close, all the time. that red cable goes there and it's powered all the time. Now let's discuss how the starter is grounded. If you look, starter's grounded like this. What do you think that means? The case of the starter is the ground. There's no negative cable, there's no negative battery cable. It's just boom, it's bolted up to the engine or sometimes to the transmission or through the transmission bell housing. Um, this connection, metal on metal, is the ground. Is there a possibility that you lose that ground? Maybe, like maybe if someone does like a full engine paint and restoration and then they just bolt the starter up to the paint and it doesn't make connection, that's possible. But generally the issue with the starter is not the ground is not good because you have all this surface area for ground. But it's possible. All right. Do you think right now with this drawn as is, the starter will run? Because that would mean the starter runs all the time and never shuts off. So you know that's not true, right? So what do we need to do to get the starter to run? Well, I think you could imagine power is going to go up through here and it's going to sit at this point. That's your ignition switch, like this. Cool, makes sense. When does it start? When you turn it to the start position. So you've got off, accessory, that's when your radio turns on at the drive-ins and you drain your battery. On means like you're turning the ignition on. On an old car, that would mean you're sending voltage to the coil. On a new car, that more means like the second click, that's when lights light up and computers come online and the fuel pump runs and stuff, right? So if you turn it to on, it's still not going to start. You have to turn it to start and then power will go through. And that power will go here and here. I'm actually going to make the line a little smaller. And if you notice right there, it doesn't go any further. Can you see why? Because that starter relay contactor is open. However, we do have it right here. So what do you think has to happen for this relay to be energized? True. So in this particular diagram, who grounds it? The ECU grounds it. So you guys notice you get in a newer car and then, on the old car, you start it, but on the newer car, you turn it to start it. Then you notice like it kind of cranks itself. So on the old cars, if you held the starter, if you held the ignition key in the start position, it would crank and crank and crank and crank indefinitely. It would just keep cranking. That also meant you had to hold it. The negative of that was like my neighbors across the street would start the car. I told you this. They'd crank it, and then I could hear the starter run, then I could hear the engine start, and then you could still hear the starter was engaged. It was so noisy. And I was sort of like, why are they still holding the key when the car's running? And it's like, right? So they were having premature starter failures. And the manufacturer said, you know what? Let's have the ECU control the crank. So if you turn the key, yes, it's going to give power to the starter relay, but the ECU is the one that actually gives the ground. So if the ECU gives the ground, what would happen if that coil has 12 volts in ground? It magnetizes, right? And then what would happen? Bingo. So if the switch closes, then you get power that comes down here. Cool? So the ECU, mainly we made it a little bit more ECU controlled. So if this was old school, you wouldn't have the ECU, you just have a ground right there, right? But on newer school, the ECU grounds it so that way the ECU can give negative until it sees your crankshaft position sensor shows some RPM, and then it's like, whoa, this car's running, take the negative away. Make sense? If the ECM takes the negative away, what's the starter do? It stops cranking, so you don't have the thing crank. Like once the engine starts, the engine tries to turn so fast, it's going to overspeed this starter gear. So the ECM's like, whoa, buddy, we got RPM now. Take the ground away, which will disengage the starter and stop my neighbors from killing their starter. Mm-hmm. Similar. Yeah, very similar. So on a push to start, we would just get rid of this. This could become your push to start, and we could have the ECU control this as well. But a lot of times, like on the push to start, we'll just, what we could do, We could eliminate the ignition switch right here and just have power go here all the time and then have the ECU get a signal from the push to start, and the ECU controls the whole thing. So we could design it several different ways. But if you look, once we've got the starter relay energized because of the key and crank, key and start, and the ECU's like, yeah, I approve of this, then the power goes through and it goes to this park neutral position switch. What do you think it's looking for here? Are you in P or N? What do those mean? Park or neutral? Yeah. Do you know you can't start the car if it's in drive, right? That's not safe. We're not trying to do that. So if it's in drive, there's no continuity through this switch. What position does it need to be in? Park or neutral. If it's in park or neutral, fine. We will connect down to here. Kind of make sense? And then if we connect down to here and we get 12 volts down to this starter, it goes to the small terminal. I got another shot of that coming up soon. When it goes to the small terminal, if the small terminal gets 12 volts, exactly what happens here is it activates a solenoid down here, which I'll show you in another slide, and that's going to make a contact, and this big positive is going to be jumped over to the motor, right? So when you go to diagnose the starter, all you really need to do, honestly, in the most basic way, I'll drop this, and let's just say we do the most simple, which to me is available voltage. All I need to do is make sure I've got good available voltage here on the big cable. And then I need to say, hey, can somebody turn the key to start? Hey, Tony, how you doing? You hold the key in the start position, and then I'm literally just going to take my meter and check the small wire right there. If it's got power on the big one, which it most likely will, and it gets power on the small one when your key's in the crank position and it doesn't start, it's the starter with a slight possibility of having no ground on the case, but that's just not really a thing. You know, if something looked weird, you'd be like, maybe that's the case, but generally we're good. And if you wanted to make sure the ground was good, you could probably change your red cable, throw your red lead on the positive cable, throw your black lead on the body of the starter, and it should read 12 volts. That's a good way to check to make sure it has a good ground. That kind of makes sense. That's essentially all your diagnosis is. The diagnosis is really not difficult on this. Now, what if you were to check with your meter and you were to have 0 volts right here? What would you check next? There's not necessarily one right answer here. If you don't have power here, you know you must have lost it somewhere, right? So then it's kind of up to you. Like you could be like, well, let me see if it's getting power coming out of the neutral safety. And let me see if it's getting it going into the neutral safety. If you had 12 going in to the park neutral position switch, I may say, they could rename this neutral safety, park neutral, range switch, whatever. It's different names for the same part. If you had 12 volts coming in, but 0 volts coming out, what's that tell you about that switch? Yeah, it's the switch. Bingo. Now you're diagnosing. That's it. What if you had 12 volts? How about this? What if you had no 12 volts right here? You had 0 volts right here. That means it's before there, right? Could it be the relay? Maybe yes. And that's where my path of diagnosis would be probably a little different, because with experience, I'm going to skip some things. If I go to crank the car and it doesn't crank, the next step I do is I go to the relay and I feel the relay and I'll say crank it. And if they crank it and the relay clicks, what that tells me is it's getting 12 volts here and it's getting ground here, because the click is a result of the magnetism, right? So if it's clicking, that means it must be getting 12 volts here and it must be getting ground there. If it doesn't click, then that means there's no magnetism occurring, or maybe the starter relay is like mechanically bound up or something, which is not likely. Then I'd be like, all right, cool. Let me pull the relay and let me see, am I getting 12 volts here? And generally then what I would probably do is see, am I getting ground here? If I wasn't getting 12 volts here, then I can backtrack up this way. If I wasn't getting ground here, unfortunately, that's when I need to go and investigate the ECU. So what I'm going to do is draw a line right here. This right side is really more like the relay control side, the control side of the relay. That's when we're more into like ECM and some computerized things. This is outside. The starter is just right here. So this starter relay is probably in the underhood fuse box. This neutral position switch is right on the transmission. It's not at the shifter. It's not in the interior of the car, generally. Right. So if I don't have a starter relay clicking, I know it's on the control side of the relay. You get what I'm saying? The control side is like the coil side. Whereas if that relay does click, then I know it's more on the contactor side. That's this side. So I'd be like checking, here, 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 right on this particular diagram. So just listening to the click of the relay is going to tell me like a lot, so much. So if that makes sense, I got multiple additional diagrams that you're going to see. So we'll trash these drawings. I'm going to grab the pointer back. We'll look at another version. You're going to notice this one's going to be very similar. All right, what's going on there? Oh, it's a manual. Yes, that's correct. You're going to notice the manual's almost the same. So now that we know that the starter is grounded to the case and the battery's grounded to the chassis, and we can also say that, look, we got a ground here and a ground here, right? Just looking at the grounds. When we look at the positive, this one's going to be very similar. Positive is going to come up. It's going to go to the big cable, right? You're going to notice the big cable on the battery doesn't go through big switches. Imagine if it's a 250 amp circuit, what type of switch would that be? It'd be like a huge lever. So we don't switch that side. We just send that one big power right to the big terminal. Then we got to send all this, we got to send electrons through all this stuff to basically trigger the solenoid, which I'll get you a good shot of. Cool, just keep this in mind. Now we're talking about the small wire. Goes to the fusible link, goes to the start. Obviously, it's only going to work when you're in start. Then it's going to go here, here, here. Don't worry, we're going to come back to that. Now on this side, what we need is ground, right? So how would we get ground to here? Clutch, start, switch. You know what that means? Depress the clutch. When you push the clutch down, it makes the contact, and then boom, we get power and ground, which means we're going to get magnetization. What's that going to sound like? Click. When you get a click, that's this contactor coming over and bumping into that little dot. Assuming we have a good relay, power is going to come down. And looky, looky, when this power that I just drew hits that small terminal, that starter is going to click and it's going to spin. Boom. That's your starter activating right there. However, this has something different. This is a cool little one I picked on purpose. If you guys have ever seen the older Tacomas and Nissans did it too, the four-wheel drives had a pretty cool feature called a clutch start cancel switch, where let's say that you're off-roading and it's extreme and you come up to a cliff and you see it's a cliff and you slam the brakes on and you got your front tires just about hanging over the cliff and you want to put it in reverse and you want to back up. You know, when you push the clutch pedal down, you tend to roll a little bit, right? You roll right off the cliff. I hope you're recording. That could be viral. You may not be there to collect any monetization on that. So what these cars would do is pretty cool is you could leave the clutch released. You could leave the clutch pedal released, which means the clutch is physically engaged, but you don't touch the clutch pedal. You just literally keep your foot on the brake, press the clutch cancel switch, have it in reverse, and you could turn the starter. And now this vehicle is in reverse. So when you turn the starter, it turns the crankshaft, which turns the transmission, which turns the drive shaft in reverse, and it'll just literally using the starter go rrp, 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 rrp. You can actually move the vehicle with the starter. It's pretty cool. That's what the clutch cancel switch is all about. So if you had the clutch cancel switch, you can see this thing can actually give ground directly. That's not the right color. This thing can give ground directly and engage the starter even if you don't have the clutch pedal depressed. So that was a rare, like little four-wheel drive cool option. The other thing I can say is if you can imagine where this is coming from. What if you had clapped out hoopty Nissan 240 and you brought it to class and we're like, hey, let's do compression testing. And it was swapped. And as part of that swap, you couldn't get it to start. So you went ahead and you bypassed the clutch cancel switch, like we'll do right here. If I bypass the clutch cancel switch, ground makes it to here all the time. What if your classmate reaches in to start the car, doesn't realize it's a manual, it's in first gear, and turns the key? What's going to happen? It is going to move forward and it's going to pin a student up against the toolbox in lab. And then we're going to say, hey, we can't be having you bring your clapped out 240s in here because somebody got hurt. We got to do an accident report and whatnot. Now you guys understand why we have the clutch start switch. The clutch start switch is to make sure your pedal is down. If your pedal is not down, it won't allow the starter to turn. Okay, makes sense? If the switch is bad, yeah, actually that student knew pretty well how to do diagnosis. If you thought the switch was bad, you could take a jumper wire and you could literally just, you could go like this. You could just jump here to here. And if it starts, that's because the clutch switch is defective, right? I mean, you could also just measure voltage. If you had like this, like let's just say we had a clutch start switch that had corrosion right here. Let's see what would happen. You'd depress the clutch, but there would still be corrosion there. So the way this would actually look is, and I'll do this in solid so you can still see. You would actually have 12 volts go through the coil. You'd have 12 volts go all the way down to here. 12 volts will go all the way to where the open is. So if you had 12 volts before and after the coil, it's because you don't have a ground connection, so just tying that back to all the electrical stuff that we've learned. You could also test this switch. So you could test to see if you push the clutch pedal down, if it has 12 volts going in, but 0 volts coming out, that means it's open. It shouldn't be open if you have the pedal down. Makes sense? Or you could even test in ohms. You could literally do red lead here, black lead here, and see how many ohms it has. And it should have like, 0.2 or something. So there's multiple ways to test this switch. There's also multiple ways to test the relay. As we tested relays earlier in the class, you could look for 12 volts here, look for 12 volts here. Then if you gave ground here, right, because you should get ground, but if you supplied ground, you should be able to do a voltage drop across the contactor on the other side. So you'd say like, if this was 12.6, you should have about 12.6 down here. But if you drop 2 volts, you know that you have corrosion on this contactor. Or if you drop all 12 volts, you know that it's not even making any kind of connection. Or you could bypass it like this. I don't know what in the world these guys are thinking. Is there any way this can wait? Does this have to be done right now? Nobody can even pay attention. That's so loud. I got a whole class full of people right here. That would be very helpful. Like an hour. You guys are gonna be tradespeople and just sometimes like wake up and pay attention to where you are and be like, in your work, you're like, I want to drill this hole, but then be like, what am I doing? Like I'm 7 feet from the classroom drilling the hole. Good. Okay, kind of makes sense. All right, let's get another. So I want you guys to remember what we're testing here, right? When you're going to test this starter, you got the big cable, and we're ultimately seeing if positive makes it to this point. But how does that look? I'm going to show you exactly how that looks. Okay, this is your big battery cable. So what should we have there? You guys remember? Big battery cable should have 12 volts. That's the big positive. So if we got 12 volts right here, that's really good. What should we have and where should we have it when we turn the key to crank? That's the small one right there. Boom. So if you got 12 volts right there, what that tells us is the relay and the neutral safety switch and all that stuff is working. Kind of makes sense? So if you do that and the starter doesn't work, what are you selling? The starter, that's it, it's done. Your diagnosis is over. That's how simple it is. If you've got 12 volts on the big cable, which you most likely do, when you turn the key, if you get 12 volts on the small wire, your diagnosis is over. Make sense? That's it. It's done. However, I'd like to explain a little bit more. This is the solenoid right here. When you send 12 volts to here, what happens is it magnetizes inside, and this plunger is going to come over like this. And what it does is it connects this big cable to this wire right here. Do you notice where this terminal goes? Right here, goes into the starter motor and makes it turn. That makes sense. Now you guys can visually see what's happening in that solenoid. So if I got it right here, you got big power right here all the time. When you give little voltage right here, this thing's going to go click and it's going to connect this big power to this one. And if you notice, this wire goes right over to the motor. That's how the motor is going to turn. All right, it's not that complicated. I think you can handle it. And that type of concept is all over ASE. And it's not rocket science exactly. It's fairly simple.
That wire,
Yeah,
you have to turn anything.
correct, because it's battery. Yeah, straight from the battery. The only one you need a little help with is this one, and that one should only be powered when the key is turned, and it gets power, if you recall in this diagram. If it's getting power down here, the key is turned and the relay is closed, which means the clutch switch is closed, or the neutral safety, like all of this is working well to get power down there. Now, if you were to go back to this, and let's say you go to diagnose the car and there's no 12 volts on the small wire, then what are you going to diagnose? Then it's like we're back to just basically testing electricity, how we test it. If we're going to test, if we have no power here, then we look at the diagram and we're like, why don't we have power down here? You know, did it make it through the fusible link? Did it make it through the switch? Did it make it through the relay? Was the control side of the relay activated? Did it go through the park neutral switch? You know, that'll mostly should make sense. Was that a knock? All right, I'm gonna leave it open. Hi.
Didn't realize it was broken.
Yeah, it was just because the hammer drill. No, it's okay. They're not drilling concrete right now, so that it does help. You don't have to not drill concrete when we're in class, but it does help. All right, so if you understood my flat rate mentality, if the car does a no crank, no start, what would my next step be? I'd probably go to the relay because I don't need to try very hard to test that. If I go to the relay and I feel it and the relay doesn't click, I know that my issue is going to be either, well, technically, if the relay doesn't click, it could be a bunch of things. Like if my ignition switch doesn't work, it won't click the relay. If my ECU is not providing the ground, it won't click the relay. But if the relay does click, I know this is good. And technically, because it's clicking, I know that all this has to be good. So I'm not going to check the fusible link. I'm not checking the ignition switch. I'm pretty happy with the ECU. What I'm going to probably check is anywhere between here and here. So the less tests I have to do, why is that a good thing? Faster. Yeah, exactly. So now you understand why automotive, it's all about incentivizing. We could very easily have the customer come in and be like, oh, to diagnose your no crank, no start, we need to test this, 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 which is going to take forever. We need to test this, we need to test this. And then next thing you know, you're like, yeah, it's going to be 4 hours for us to figure this out. And really, who's the customer to say like, no, because if we all did that, they'd have no choice. But it's a healthy level of competition when we're saying, well, I know the system so well, I can figure it out in less time, and I can therefore charge less money. Or sometimes how that works is I'm going to bill you the same amount of time, but I'm only going to spend a little bit of time on it. And to the customer, that's a ripoff. But like if you really think about it, if we get the correct diagnosis and we arrive at that correct diagnosis more rapidly, are we really ripping anyone off, or are we just getting really good at it? Are we just getting really good at our trade? In which case, should we be penalized by being good at our trade by having to work on double the cars for the same price? Or if we were able to work on double the cars because we really understand it and we're very fast, should we get paid double? And probably most people are gonna agree with the second part of that. So if you really get this down and you really know what you're doing, you get diagnosis very quick, and then you can move on and do, you know, double the cars and make double the flat rate time. That's the idea. Cool. So that makes sense. And now you know what that looks like right there. You can kind of see this. And so sometimes we'll use terminal numbers and sometimes we won't. But if we understand pretty well that we need 12 volts to make it up to this point, and we need it to make up to this point, let's talk about what happened right here. That's, in this case, terminal 50. It may not always be 50, but in this case, it's 50. Sometimes in the domestics, they'll call that the S terminal. So this one right here would be the B terminal for battery. And this one right here we'll call the S terminal for solenoid. All right. So we have positive on B all the time. We have 12 volts only when the key is on and the relay and etc. makes it to S or terminal 50. If we get power to terminal 50, it's going to magnetize this coil, right? If that makes sense. And then our big positive, which can't touch. Do you see how it can't touch right now? When this thing goes over, now your big positive passes through and goes to the motor, goes to the windings and makes it spin. So there is a contactor right here. And that's a lot of times a potential failure point. So like back in the day, my high school auto teacher was explaining how you could test a starter with a screwdriver. And I was like, there's no way, there's no how. Well, here's exactly how. If I came over to this one, and this is not a screwdriver, but let's just say it was, I've got big power coming in on this terminal. I need little power to close the solenoid to connect to the starter motor terminal, which on here, we would generally call this one M, or in this case, C. So the M terminal, we could go with a screwdriver from B and jump it over to M and make it spin. So if I went from B and jumped it to M and it went zzz, why is that the case? How? Who, how, what, why? Well, I'm bypassing. If you will recall, if I delete all this, you will recall when we get this terminal 50, or AKA S terminal power, it should pull this over. And you see this disc? That should contact right here. And if this disc contacts right here, and this disc contacts right here, that should give big battery power to the starter. But if these contacts right here are messed up, we could bypass it with a screwdriver. And if it makes it turn, you know the contacts are messed up. Do you know how we replace the contacts in here? We get a new starter, right? That would be a bad solenoid. So if you ever hear the term, that starter has a bad solenoid, it'd be like this test. Sometimes the solenoids don't have the power to pull in, and other times the solenoids have corrosion on the contactors and you can bypass it with a screwdriver. Not a little wire though. If you try to do this one, this wire ain't gonna handle no 200 amps. It's a poof, it'd be burnt up fire. Hazard. Kind of makes sense? So if it does work, however, and all this stuff happens, and the B plus goes up to here and it spins the starter, what also tends to happen is, remember how it pulled this in? Well, it also kicks the gear this way. And if it kicks the gear to the left, now you got this gear engaging this gear. So the solenoid in this case has two purposes. Purpose one, it kicks over to make the contact right here. Purpose two, it kicks over to engage the drive gear with the flywheel. Makes sense? Mm-hmm.
Shorted that out right there, so how does that prove that that's not working?
It just proves that this contact, if you can jump from here to here, it'll send big power to the motor. It'll make the motor run. It means something is not working in the solenoid. It could be two things, I'll admit. It could be bad contacts here, but it could also be maybe your pull-in coil is no good, which means it doesn't kick it over this way. Kind of get what I'm saying? So if you jump it with a screwdriver and the motor runs, it tells me all this is good. The starter's good and all that. But why didn't it work when I sent 12 volts to 50? Either this winding is no good, which means the solenoid would not click. Get what I'm saying? If this winding is open, you'd crank it and it would just do nothing. That would be more like a winding. But if it clicks and it still doesn't run, then that would more be like the contactors. That sort of makes sense? So if you go to a starter, put your hand on it, and you hear click, 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 but it doesn't make the motor vroom, 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 it'd probably be the contactor in the solenoid. But if you start it and you hear no click, and you check and you have 12 volts going to that small wire, it's probably actually the pull-in coil right here. So it's kind of interesting because people will say, oh, if a starter's bad, it just clicks, or if a starter's bad, it doesn't click, and they're both right. But neither one of them are conclusive. The starter can fail in many ways. What if the solenoid was good, but we had a bad winding, let's say, up here? Well, then power would make it here. This thing would click. This would pull in. All that would be good, but the starter would just not turn. Kind of make sense? So the starter can fail a bunch of different ways. Ultimately, what matters to us? Well, what I would do is just make sure that we have 12 volts here. Make sure that when the key turns, we get 12 volts here. And if essentially anything, if the starter makes noise, if the starter doesn't click, if the starter does click, if the starter clicks but it doesn't move, whatever, it doesn't really matter. It's a bad starter. Then the person who rebuilds it would like to know, like, hey, did this starter click? And you'd be like, yeah, it clicked, but it didn't run the motor. Then they might be like, maybe it's the contacts in the solenoid, or maybe it's a winding in the motor itself. Or if it doesn't click, maybe it's an open circuit in the pull-in coil, but again, we can cut a lot of that out because you just truthfully really don't need to know. I don't really need to know either. I just want to know more than I need to know so I can do a good job for you. That's what I want. Exactly. It's disposable. It's kind of like an engine. Back in the day, we used to rebuild engines, and we still do a little bit, but like ultimately, if you determine the car's misfire is caused by the engine, we're not super worried about, is it an intake valve? Is it an exhaust valve? Is it rings? Is it a hole in the piston? Is it worn cylinder? It's like we're putting an engine in it. It's kind of like, do we really care? Maybe a little bit. But if it's a starter, we really don't care at all because we throw it in the box as a core charge and they take it back and somebody else fixes it. That's why we give them the core though, because they are going to fix something probably minor. When you send it back to be rebuilt, they're not replacing this motor and this solenoid and this gear and this one-way clutch, which we haven't even covered yet, right? They're just going to fix what it needs and spray paint it and sell it back to you, which may or may not last that long, which is why now you see I put the OEM in my truck because I couldn't risk it. Kind of make sense? And this is pretty much what happens. If you see, boom, when you give 12 volts to that terminal 50, bang, it pulls that in, makes the contact, and get this whole thing starts moving. And this one is a gear reduction starter. That's why there's multiple gears. So this starter can be small because it could be a gear reduction starter. The bigger starters, because we didn't have gear reduction, it was a bigger motor turning a bigger gear. And they didn't have to spin as fast, whereas the new ones, the motor spins really fast and gear reduces. And if the motor spins 3 times as fast and it has a 3-to-1 gear ratio, it'll make 3 times the torque, but it'll be smaller. So again, kind of a detail that's not critically important. Right, so that would make sense. And then here you look at, this is what we may call the armature and starter drive. This is the actual motor part. These can fail. If you have an open winding in one of these, it might work. Let's say you had 20 segments on this. If you had one segment that had an open in the armature, that starter may not function 1 out of 20 times. And additionally, the starter's probably not going to turn quite as fast because that's like a 20 segment, but it's only running on 19 out of 20, right? So this is another potential failure point. But again, like if that's the failure and we check and we make sure the starter has 12 volts on the big terminal and 12 volts on the small terminal. Like we don't exactly care what the details are, but just so you know, one of these segments can fail. And the other thing that this is good for is if you look right here, this whole starter has to be supported because this thing spins, which means we've got bearings and bushings to support this. And so one of the things we're going to cover in a moment is how do you know, like if we looked at starter draw, how would you know if a starter's failing due to maybe excessive resistance in these windings or excessive resistance in that solenoid versus what if it's got a lot of mechanical drag on the bearings? Okay, so I want you to remember this. If it's got bearings and bushings, those can fail and it'll be harder to turn, right? If it's harder to turn, it's going to draw more amps. But so more amps would be like a mechanical resistance. But if it's an electrical resistance, that's going to be less amps if we recall Ohm's law. Remember Ohm? The more Ohm pulls, the less amp flows, right? So if there's electrical resistance in here, your amps are going to be down. So if you want to really diagnose a starter as whether it's a mechanical resistance or an electrical resistance, you just need to measure the amps. Can that make sense? Don't worry, we'll come back to that. This is just a good visual. So here we got gear reduction style, different types. You know, they have different types and shapes and sizes, but this is one of the things that I wouldn't cover as much as, you know, some of the curriculum from the book and whatnot. There is one more important part. When you go to do the starter, right, like my neighbor across the street, you engage the starter, it's cranking, cranking, cranking. When the engine starts, the engine goes much faster than the starter. So if the starter's still engaged, the engine is dragging the starter along for the ride. Do you think your starter's very happy with that? Now you understand partially why we use the computer, the PCM or the ECM to disengage it. Like, hey, I see crankshaft signal, like back off. But before that, we did have a one-way clutch. So this has a one-way clutch. I can turn it this way. I can't turn it that way. That's an example of a one-way clutch. You may call it an override clutch as well. So in one direction, when you're cranking the starter, if you look at these balls right here are fitting really tight up against that inner and outer race. If the engine starts to spin this starter gear really fast, it's going to roll the ball against the spring. And if you notice, it gets a little more loose up here. The ball is going to kind of relax and it's going to stop it from spinning. So essentially it's a one-way clutch. If the starter is doing the driving, the ball locks and it drives. But if the starter starts being driven by the engine, it'll freewheel, right? Freewheel. What do you think a potential failure point would be? What if it freewheels both ways? It'll try to turn the starter, but this gear will just freewheel and it won't actually move the engine. That makes sense. So the starter one-way clutches can fail too. So if you got a starter that spins, like you can hear the motor spinning, but you look at the gear, you look at this gear and this gear staying still, it's a good chance the starter one-way clutch has failed, which means it needs a starter. So it's not really a big deal, but that's very similar to that flywheel that overheated and the ring gear released, and it was just spinning the ring gear but not the flywheel. Except in that case, it needed a flywheel. In the starter one-way clutch, it just needs a reman starter, and it comes with the one-way clutch. That's going to be good. How do you check it? It's really easy. Spin, good. Doesn't spin, good. Spins both ways, no good. Make sense? Of course, you got to take the starter out to do that test. So I would probably recommend just doing the diagnosis as if you hear the starter turning and you look at the engine not turning, you're going to be like, it's either the starter one-way clutch, most likely, or it could be a broken flywheel teeth or a stripped flywheel teeth or something. Cool. Um, and if you look, here's the teeth. You can just see them like if you were to be able to peek in there. You could also try to use a pick and push it this way, and it might freewheel one way, but it should lock the other way. That's another way to check that. But you wouldn't check that for no reason. Like if the starter's working but not cranking the engine, that's when you can get in there and check that. You wouldn't just be like, oh, the starter doesn't work. I hear no click, no nothing. Like, don't waste any time on this. This would just, this I would just do if it had a symptom of a bad one-way clutch, which would be well, a couple things. If we're testing the one-way clutch, I want to push on the teeth and see if I can freewheel it and see if it locks. But also, if we look at the teeth, let's think about this. This starter has to engage the flywheel. So if the starter is supposed to engage the flywheel, but let's say the starter is not set at the right depth, or maybe the solenoid is not kicking it out all the way. What if it starts to catch just the edge and it's only contacting 25% of the teeth? It could actually start to rip those off. They can start to wear. So if we're looking at the starter, we're going to look and be like, hey, are these teeth looking good? If these teeth are looking messed up where it engages the flywheel, if we messed up the starter teeth, which other teeth do you think we messed up? Probably the flywheel teeth. So I'm telling you this because I don't want you to tell the customer, yeah, it needs a starter. And then you go to do the starter and the teeth are all jacked up and you got to call them back. And well, maybe you put the starter in and they leave and then they come back like a day later being like, hey, it didn't start again. And you're like, oh yeah, I noticed when you brought it back the second time, the flywheel teeth are all jacked up. Be a good idea to look at that first. Typically, if the flywheel teeth are jacked up, you can hear the sound. They'll scream. Or I've even seen it so bad where you'll go to start it and you'll hear the starter like turn and banging, and you can see the engine try to turn like. You're like, ooh, that. I'm gonna check those flywheel teeth or those flex plate teeth. They could definitely be messed up. You can see it really good here. Here's your starter. We'll call that the pinion. And then here's your ring gear. This is your flex plate or your flywheel. This one's a flywheel. That's the clutch surface. So these teeth will damage these teeth. And if you put a new starter in, these damaged teeth will damage your new starter. So if the teeth are damaged, you got to really do both. Anybody know what you got to do to replace this? Hold the transmission. So we don't just want to replace it because, but if it needs it, you really need to make that known to the customer and just say, hey, you got damaged flywheel teeth. You need to do both. It's not going to be a $300 starter. It's going to be a couple $1,000 pull the transmission job. And they'd be like, can you just do the starter? And then at that point, I'd say, I can, but you're going to sign some waivers saying that this isn't really going to address the problem. You're just fixing like a part of the problem. It's probably going to ruin your starter over and over and over, or decline the job. But I don't think I would just be like, yeah, it might be all right, because, if they sue you and then they're like, yeah, they should have replaced my flywheel, my flex plate or whatever, and I was here and I was there. Next thing you know, they're like, you knew better. Like, you knew those teeth were damaged. You should have done something, right? So we at least got to be thorough and recommend it at a minimum. Cool. So this just gives you a good shot of the three-dimensional. Here's your solenoid. Here's that plunger with the contacts. When we send big power to terminal 30 in this case, and then we send little power to terminal 50, this solenoid winding pulls left. It connects the plunger. It connects terminal 30 to the motor terminal. It's going to send power up here. And this motor is going to do the thing we were talking about, commutating and switching positive and negative, and do attract, repel, and all the magic stuff we discussed. And when it does that, it's going to drive this gear, which drives this gear, which drives this gear, which is then going to get kicked out because of the solenoid and engage the ring gear on the flywheel and turn that, right? So there's kind of a lot of stuff happening in the gear reduction, but it's what we're here to do. Cool. And that's your, again, a different shot of the one-way clutch. Like we talked about the overrunning of the one-way clutch again. All right. Now, with regard to motors, I'll breeze over, but I won't go crazy. You could have two types, electromagnet or permanent magnet. Rather than go through a lot of the wording, I'll just show you. Permanent magnet is where these are just magnets, period. They're magnets, that's all they are. They're just magnets. Whereas this is electromagnets. These are only magnetized when we give them 12 volts and ground, like a relay is an electromagnet. So we could do one or the other. If you want to do, let's say in this case, This is electromagnets. We have to magnetize this, let's call this the rotor and this the stator. Sometimes they'll call this the armature, but the rotor rotates and the stator, the reason we call it stator is it's stationary, so you all know. On this electromagnetic type, we have to magnetize the rotor and the stator. So we got to electromagnetize both of them, which means we got wires going to the rotational part through that commutator thing with the brushes. Here's a brush, for example. Now you'll notice this has a lot more, this is more realistic. This commutator is switching positive, negative, and negative, positive every little square. See how it switches a lot? And each of these is a winding, a winding, a winding. So you see how you have a lot more windings? If this had 30 windings, that's given us almost like a 30-cylinder engine rather than a one. The original one I showed you was like a one. This is how it really works. So we got all that stuff happening, but then additionally, we need to switch back and forth the stator magnets. So that's more old school. If you wanted to go with a permanent magnet, which is what I'd focus on, a permanent magnet would be like right here. You have the armature that spins. That's got to switch positive, negative through that commutator with the brushes. But these magnets are just magnets and that's it. So it's a lot smaller. It's going to be more reliable. You don't have to worry about windings on the stator and windings on the rotor. The stator is just a permanent magnet. That's all it is. And the rotor actually has to switch positive, negative, negative, positive, positive, negative, right? So this is more simple. Makes more sense to me. Not a super big deal. Still got the brushes though. So we're not talking about like a brushless motor. I don't know of any starters that are brushless motors, at least not yet. But here's an example of the brush connections. You can actually see the brushes being pressed up against the commutator. There's a spring right here, and this is the little lead that's going to be the positive, and this is the little lead that's going to be the negative. All right, so this, if you wanted to replace brushes on a starter, you actually could pop this off. You could probably buy brushes on Amazon. You could probably put brushes in it. To do that, you should probably clean it all up. If you really want to rebuild a starter, you could do it. It's not really rocket science. It's just, if you rebuild a starter for a customer and you don't deal with the one-way clutch or you don't deal with, potentially the bearings or the bushings, and then they're going to be like, well, ever since you fixed my starter, I still have this other issue. So by the time the starter fails, it's probably ready for more than brushes. It probably needs some bearings. It may need the one-way clutch. It may even have a problem with the winding. If somebody banged on it, it may have cracked a magnet. So mostly for liability purposes, we don't really get involved in that, right? If we put a reman in it and the car comes back with a starter problem and it's an AC Delco and you're, a legitimate shop, you're like, hey, I put an AC Delco starter in there and the starter failed. They'll be like, cool, we'll send you a new one. But see, if you're a shop, they'll also issue a labor payment for warrantying of that part. So like some of it's liability. The customer's upset. Well, hey, we put a reman starter in there. It was O'Reilly's fault or whatever. We're going to take care of it, but also O'Reilly's is going to pay the bill the second time. A lot of technicians, like myself included, we're not interested in doing the job for free the second time. I want to do it one time. And if I rebuilt it and my rebuild, I missed something or whatever, now I got to eat it. And I'm not hungry for that. Kind of makes sense. That's mostly why we're doing what we do. And then also in the rare event that something happens related to customer safety due to the rebuild, I would rather have that than the rebuilding facility that does them all day. They're probably a little better at it. They're probably a lot better at it. I'd like to think so, right? I would want, if you're trying to build a really high quality relationship with customers and your customers are not cheap, I do OEM every stinking thing. However, customers are cheap and they want cheap labor and they want cheap parts. The only thing is like if a reman starter is $150 and the OEM is 600, it's going to be hard to get the customer to go with the OEM. Be like, hey, if your car is 20 years old and you put an OEM one in, that's amazing, but you just put $600 part on a car that's worth $2,000. Like maybe you should go with the $100 one or 150, But ideally at my age right now, I don't really want to deal with that. I would rather honestly put an OEM in, not worry about it, not get a call from the customer. The side work thing is good. You guys, for real, if you get good, you can make a bunch of money. But when you're trying to keep these cars alive and you're working on a Tuesday and the customer is texting you at lunchtime on a Tuesday saying, hey, I need my car fixed. It broke down. The starter you put in 3 months ago didn't start. And I'm in the parking lot and I want you to come get it. And I need you here and I need you whatever. And it's like, I got to do my job. And it's, and it's an O'Reilly's starter, like call them. O'Reilly's doesn't go get a rescue. It's on you. Then you got to be like, I can't touch that car till Saturday. Then it's up to you if you really want to do that side work. But right now, I give you all the side work I got. And there's messages on my phone that are not even, I haven't even looked at them. I know what they're about, but I'm like, I'm not working on it. Just real talk. However, we can see the brush connections. In here, it's a little hard to see, but the springs are behind the brushes. So the springs push the brushes applied. As the brush gets thinner and thinner and thinner, that spring is more and more extended. See how the spring's not going to keep nice tight tension as the brush is thinner and thinner and thinner? That's a lot of times the reason we bang on it and it starts to work. Right, so pretty good. And you can see this is generally the same example as before. And this is just walking you through how and why and you know, if you have positive and it's making a magnetic field going in this direction, and then you switch it through the commutator, it's going to make it go the other direction. That's the attract and the repel. Again, the starter's designed to be that way, so we don't have to do all that much with that. I think overall, you guys will probably pretty much get it. This is a solenoid that's a nice visual. If you've got a start switch that's old school, push button or whatever, all the start switch is really doing is connecting your positive big battery to your solenoid wire. And if you do the solenoid, that's going to magnetize this coil, which will pull this in, make the contact, kick out the starter drive, and it should be turning because the motor is going to do the positive, negative. Right. So that's not super new. And that one was just showing the small wire as the S. Okay. Just so you know, that's the solenoid wire. This one is your B, that's positive battery. And then this one is generally your M. That one goes over here. So the screwdriver trick, that's just connecting this with this, which has power all the time. If you send power all the time directly to the motor, it should make the motor run. And if it does, that tells you either you're not getting power here, or if you are, it's not making an internal contact on that disc, which means it needs a solenoid. So probably overall pretty good. I think with this we're good. Let me jump into what I feel you're going to benefit from the most. This one's good. If you want to start this car, let's trace out what happens. We'll do the grounds first because the grounds are easiest. The ASE is going to have quite a number of diagrams, so I've got a bunch prepared. Ground right here, ground through here. Okay, this one is grounded all the time. This one does not look like it's ECM controlled. So this is your first one, non-ECM controlled. When we go to do power, it goes to the battery all the time. We agree on that, right? That's the B terminal, big battery. Then power is going to go through FL main to alternator, but it's also splitting off to these two, which are different fuses, to the ignition switch and to the ignition switch. So you have one ignition switch that's going to close both of these. When you turn the ignition switch on and to start, it's going to do a couple things. Going to send power down here, which is going to magnetize. Actually, it's just going to go to this side of the relay. That's the switching side. So it's interesting, this relay doesn't even get power until you turn the ignition switch on. Then when you turn it to start, the other switch, which is in the same housing, it's like a double pole single switch, is going to be sending voltage down here. What do you think has to happen at the park neutral position switch? Got to be in park neutral. If it is, it goes through here and it goes here. Now this is the coil side of the relay. So if we have 12 volts on the top and ground on the bottom, what happens? Magnetize, yeah, and the switch will close and you'll hear the click. And if the switch closes and you hear the click, assuming the contacts are good, this will come down, go to here, go to here. This right here, that's that S terminal. That's the solenoid. If you give positive to the solenoid, that's going to magnetize this. That's going to pull that disc over like this, if you can see it. I'll change over to a small pen. If it gets pulled over because the magnetization, this is going to be contacted here, which is going to send big power through the motor, make the motor spin, right? That's it. So if we were to look at it right here, if we get red right here, that's going to magnetize it. And what that does is it draws this. You notice how this is kind of like a relay? That disc I was showing you in the solenoid is kind of like a relay. We use the low amps right here to magnetize it, and then this is going to get pulled over to here. And then if you recall, the big power came in and died. But now that we have magnetization of the coil, it connects, goes to the motor, runs the motor, makes the motor turn. Right? That's it all day. That should have you understanding the starter 100%, at least how it functions electrically. But wait, there's more because we still haven't talked about other ways to test it. If you had the crank and hold feature, that's when we're going to integrate the ECM, right? So if you look at this one, you'll notice a lot of the stuff is the same, but what we do have to do is add the ECM. So if you look at the ECM is looking for a signal from what? What's it say right there? The crank sensor. So the ECM is willing to give ground to the relay, if you look at it. Actually, in this case, the ECM is giving power, right? The ECM is going to give power to here, but it's going to have come through all this. Cool. So if the ECM is happy, it will give power to STAR. But if it sees a signal from the crank sensor, what do you think it's going to do? Not give power to STAR. And if it doesn't give power to STAR, it doesn't magnetize the relay and the starter shuts off. Get what I'm saying? So the ECM is like, yeah, you can have power. Then once it sees crankshaft speed, it's like, no more power for you, starter shuts down. That way it's not engaged. That way it's not so hard on the one-way clutch. Plus it can also, the ECM can get a signal initially and be like, oh, they want to start it. Let me take over. I will hold the starter engaged until I see the correct crank signal. So you don't have to sit there and hold it. You just hit the start button and then you can let go and it'll keep cranking. That's how that feature works because the ECM is controlling the power to the relay. Cool. That's fairly simple, I think. And this just more is the graph of how that works. It's got a limit of 2 to 25 seconds. If this system cranks it for 25 seconds and it doesn't see crankshaft RPM come up, what do you think it's going to do? Shut it down because it doesn't want to overheat the starter. It doesn't want to kill the battery, but mostly it doesn't want to kill the starter. It's a good system to make the starters last longer. And sometimes things about perception. So if the starter lasts longer, that people feel it's more reliable. And they build a good starter, but they also added this ECM control that prolongs the life of the starter. And everybody's happy with how much more longevity they get. However, for us, now you got to understand you're not just testing the circuit in this way, you're also having to test STAR positive from the ECU. So you might have to actually get involved in some ECU testing a little bit. It has got more complicated. All right, so say you roll up to the car and it's got a problem. Let's go over some of the tests. First test, visual. If you have a car that doesn't start, you obviously are going to start with a visual. You may see things chewed. You may see damage to the starter. What if you see a bunch of corrosion here? What if you see corrosion here? Those are all clues, right? So a visual inspection you should start with. However, if you see corrosion here Or here, while you might, say like we got to take care of that first, generally the more professional approach is we have to diagnose it. So if what would the corrosion cause? You tell me. It might go slower, high resistance, you might have a voltage drop, right? All things that we can measure. So if you think that the corrosion is the cause of the problem, see if it makes sense. So if this car has a no crank, no start, and you see some corrosion on the battery terminals, it would have to be pretty severe. But what you could do is you could do like put your positive lead right here in the middle and then put your negative lead a little further down on the terminal. You can measure the voltage drop at the terminal. If you've got a 0.5 volt drop at the battery terminal, is that causing the no crank, no start? All right, let me reword it like this. If you had a light bulb that was not working at all, it's totally out, is that being caused by a half a volt drop on a connection? No, that's not enough drop, right? So like the thing that I mostly want you to understand is yes, by all means, do the visual, but the results of the visual need to make sense. So if you have some corrosion and you're like, oh, that corrosion, we need to take care of that. Well, the customer's concern is the car doesn't start, right? And if the car doesn't start, it could be a number of things. And if all you say is, well, we have to do the maintenance first before we can do the diagnosis, that's going to be very frustrating. Because what if the car's on its last leg and they just want to know, like, can I fix this car for 500 bucks? If it's more than 500 bucks, I don't want to fix it. And then you're like, well, hold up. We need to do like a battery terminal service before I can even tell you. Think about that if it's the medical field. Grandma walks into the doctor and grandma's got a runny nose. But grandma's also got like, a major problem with, pain. And the doctor's like, well, wait a minute. I can see your nose is running. We need to make sure we take care of your sinus infection or your maybe it's even more minor. We need to treat your allergies. But in the meantime, maybe that's not the cause of grandma's pain. Maybe grandma's got bone cancer. It's sort of like too many technicians would be like, well, I found something. I found some corrosion. It's like, all right, is that the big problem or is that like a little problem? If the car doesn't start, corrosion's relevant, but is it the cause of the car not starting or not? Make that determination however you can. You can probably measure that voltage drop across the terminal. You can probably see how much voltage is available down at the battery. And if you're getting 11.7 volts at the starter, we're not real worried about the battery corrosion. That's something we can sell as a maintenance, but if the major problem is that the starter's bad and it's 300 bucks, we should probably address that and then say, hey, you should also clean the battery terminals for an extra such and such. Kind of make sense? All right, but we could also do current draw test, which we're going to go over. That's going to tell us a lot. Voltage drop test is going to tell us a lot. Operational and continuity test, which is a good way to do it, but there's other ways. Or worst case, a bench test. Do you guys know what a bench test is? Bench test is what O'Reilly's offers the DIY person in AutoZone. The customer doesn't know how to diagnose, but they can take the bolts out and they can undo the terminals and then they can bring it in and say, can you test this? And they put it on the bench and then they put big power here and then they jump little power right here and it should kick out and go zing. And if it does, they're like, yeah, your starter's not bad. Take it back. Or if it doesn't, then they'll be like, yeah, your starter's bad. Why do you think that the parts store offers the bench test? Bingo. If the starter's bad, they're like, here, we got a starter for you right here. Go on, put it in. But then if they put that starter in, it still doesn't start. They're like, well, we don't know. We're not technicians. We're not mechanic. We just sell parts and we offer like this service, right? So a bench test is it's really like a DIY test. So for the technician, we don't test starters by taking them out and sending them down the road. We're going to test it in the car using all these tests. So we'll go through a few of these. They're very relevant. Just keep in mind, if it's a no crank, it could be the battery, like I said. It could be the starter, like I said. But also, it could be a problem with the wiring. It could be a problem with the B plus to the magnetic switch with the ignition to start. So like maybe we have a problem in the ignition switch. Maybe we need to make sure that the key turns correctly, voltage drop. We can verify the starter operation when the switch is bypassed. So we could bypass this switch. We could bypass the starter solenoid. There's a bunch of tests that we could do to figure this out. And it could be these, and it could be other ones. So let's talk about the first test. And this is probably not the first test I would do, but this test shows you the most. If we did a starter draw testing, here's how we'll do it. And we could check with our meter and with a starter and with the ammeter. So if we're looking at our voltage right here, that could tell us a lot. But if we're looking at our amperage right here, that can give us a little more detail. So let's say, for example, if you went ahead and you connected this amp clamp on the ground, you could technically do it on the positive too. You can connect this amp clamp somewhere. This is going to measure all the electrons that are going through it and show that number in amps. All right. So if we're going to go ahead and do this test, like, you know, I have a chart somewhere in here. It's all right. We'll do it. We'll do it just how we show it. I pretty much know the numbers offhand anyway. If we go to do this test, if it's a, what do you want to work on today? A 4-cylinder, a 6-cylinder, a V8? What you want? I don't know the 12 numbers. A V8, I think is going to be 250 amps would be pretty normal. So if we're expecting 250 amps, we could do this test and put our inductive clamp over it and crank it. If we got, let's say, 100 amps, that tells us something very different than if we got 350 amps. If we got 100 amps, that means the amp flow is low. Would you agree? Because the spec was 250. And if we got 450, the amp flow is high, right? If we got amp flow that's low, that means we have not enough amp flow. That means we have too much resistance. Remember the image, right? The one that you're going to get tattooed so you can go past the ASE. If the amps are not flowing enough, it could be because the ohms are pulling really hard, right? So there's probably excessive resistance in the circuit. Excessive resistance in the circuit could be the battery terminal connection. Remember, the corrosion could do that. A battery terminal that's got voltage drop could do that. Excessive corrosion in this contactor disc, like we were talking about, could do that. Excessive resistance in the windings of the motor could do that, right? See what I'm saying? Electrical resistance will cause low amps. But let's say we got 450 amps. That's not going to be electrical resistance. You have too much amps. Why would we have too much amps? You think you know? It's mechanical resistance. So if you had bad bearings in the starter and it was very hard to turn, that would cause high amps. What if you had an engine that ran low on oil and it's kind of seized, maybe not like totally seized, but maybe it can turn a little bit, but it's really hard to turn because the bearings are seized. That's going to cause high amps. What if you had the engine that's healthy, it's trying to turn a belt, and the belt is trying to turn an alternator that's seized? That would cause high amps. So a lot of mechanical resistance will cause high amps. A lot of electrical resistance will cause low amps. That's pretty much it. That's what I was saying. The amp draw test can tell you a lot. So let's just say you rolled out to a diagnosis, as I did. I'm going to improvise slightly. But this was a customer who said, hey, my vehicle won't start. It's a Tundra. And I'm like, cool. Yeah, it won't start. Well, when's the last time it started? It's been a few months. All right, cool. So when I get there, I'm like, whoa, this thing looks like it hasn't moved in years. And I'm pretty sure it's been years. So I'm like, all right, let me check it. The battery's totally stone dead. You can't really test a starter with a dead battery. So I'm kind of like, did you just park it for a while and the battery died? And he's like, I don't know. So the battery's just, you can't even do much of anything. I tried to jump it, but the problem was he had it pulled up to his garage door and I couldn't get my cables to reach. So I'm like, honestly, to diagnose this, you got to start with a battery. Now, the battery may not fix it, but I can't do any of my tests with a dead battery when I can't jump it. And the battery's so dead it won't do a charge or anything. So he said, okay. So I put a battery in there. What do you think happened? Still didn't start. It just went click, click, and that was it. All right, cool. So now what should I do? Well, it's a number of things I could do. But let's just say I wanted to do an amp draw. Well, if it was excessive terminal resistance, if it was a battery terminal, if it was a cable resistance, if it was electrical resistance in the starter, what would my amp draw be? More or less, high or low? It's a V8 Tundra. Yeah, if I had electrical resistance, exactly. But in this case, I had very high amps. I'm like, whoa. I put a new battery in there and I go to crank it. It just goes click. It doesn't turn over and it has really high amps. What are your thoughts? Maybe. It's something mechanical. Bingo. So something mechanical, right? So my next step was very simple. I went under, I put my breaker bar on the crankshaft. I tried to turn the engine. You know what I found? Can't move it. What do you think? Engine's locked up solid. The diagnosis was that simple. And I know he had a couple of people check it out over the years, and they're kind of like, the problem was on that 4.7 liter, you know where the starter is? It's under the intake. So he had in his mind that it was a starter. He told me it needed a bad starter. And I was like, well, I'll diagnose it. Kind of like, well, I already had it diagnosed. And it's sort of like, look, if you had it diagnosed, call homeboy that diagnosed it, because I'm not going to do something that somebody else said. And then when it doesn't fix it, you're going to blame me. Like, I'm just going to re-diagnose it, take it or leave it. Re-diagnosed it, engine's locked up solid. It was very apparent because the amp draw was too high. So I checked that next. Now, to be entirely sure, I took the serpentine belt off. Right? Why did I take the serpentine belt off?
See if it's gonna.
Yeah, because what if I took the belt off and then it turned good? Then it would be like one of the belt-driven accessories, such as an alternator. Make sense? That's why I took the belt off. This is all over the ASE for the record. I took the belt off. It was still locked up solid. So I told him, hey, I think your engine's no good. He's like, no way. That's impossible. It's the 2UZ. They're bulletproof. I'm like, well, I don't know all the history here, but I'm just letting you know this engine's locked up. I go in and I pull the drain plug. Disco party. Ooh, very flickering and glittery. And it was very metallic. And I'm like, oh, yeah, this is junk. So he's sort of like, well, what do I do now? And I'm like, you want to put an engine in it? I'll price it for you. Like a legit LKQ engine with any kind of warranty is like $3,500. This truck is hammered. The frame is bent. It's all beat up. Well, somebody help. So I'm like, you could do an engine, but it's going to be, you're looking at $5,000 minimum. He's like, forget it. I'm not going to fix it. How much do I owe you for your diagnosis? What would you charge him? Keep in mind, I did go get the battery for him too. You could bill him whatever you want. Yeah, you could charge him a few $100. You know what I charged him? What are you going to do with the truck? I think I'm going to junk it. I'm like, well, sounds like you don't have a bill. I'll take it. That's how I got Bessie number 3. So that's my Tundra that I have right now. That's how I got it. You want to know what was wrong with the engine? I did a whole diagnosis on that. It turns out it had a radiator that failed because I saw the radiator was new. So I'm like, oh, the radiator probably leaked. He probably ran it low on coolant. You know what happens if you overheat it? Well, if you get it super, super, super hot, it'll tend to have the head gasket blow. So when I pulled the head off, you could see coolant was going right into the head, right past the gasket. From there, it got so hot, it actually seized the valves in the head, and the piston came up and broke off 6 valves. I had 6 valves laying in the cylinders. After all that and hooking it up, and I put in a used engine I got a lot cheaper. When I had to run it for like an hour with white smoke billowing out of it because so much coolant was built up in the cat. So this one, it took a small resurrection, and now it's back into service. But it was interesting because in his mind it was a starter. It was definitely not a starter. Lesson being, high amp draw, it could be the starter bushings or bearings. That's true. But the next step would be turn the engine itself. And if the engine turns really hard or not at all, it's not this. This isn't, when you're turning the engine, you're not turning the starter. Now, if the engine turned normal, then I might suspect bearings or bushings in here. But It's not the case. So just being able to diagnose that pretty much got me a decent truck with a long bed so I can haul a bunch of stuff. All right, but let's say we're to flip the diagnosis and say we're to roll up and it were a no crank, no start. We could not check starter draw, but we could check voltage. So what should I get? What if I got battery case? Let me check this. We're actually doing we're voltage dropping the battery cable here. So positive battery cable at the beginning of the battery to positive battery cable where it's at the B terminal. We should drop less than half a volt or less. That's how you check the cable. So you don't sell the cable, you measure the cable, the voltage drop. What about the battery terminal? Look at this. We got the red lead on the battery post and we got the black lead on the terminal. And that should be 0.1 or less. That's how you check the terminal, right? So if you take anything away, just know you don't just change the cable, change the terminal, change this, change, like we can do measurements. Your voltage drop measurements can be very effective, right? Now, if we were to do it on this side, I would imagine from here all the way to the S terminal, we should probably drop about a half a volt or less, right? So if you want, you could battery cable test using voltage drop. Half a volt on the big cable, but you could also voltage drop the small current side, the small wire side, and you should drop about a half a volt too, right? So if these are all passing, right, like this test tested the terminal, this test tested the cable, you could do another test testing the wiring on this side, right? That's how you test those parts. Personally, this would not be my go-to. My go-to, I would, and you can also voltage drop test the ground, by the way. So this is from the ground to the actual case of the starter. That's a good way to test the chassis ground connection, 0.2 volts or less. And same from the battery terminal negative to the chassis, 0.2 volts or less. And then the battery terminal on the negative is the same as the positive, 0.1 volts or less. These are all the voltage drop tests. So if you hear about starter voltage drop testing, this is it. These are all starter voltage drop tests. Now, if you think about what that means, which by the way, that's not the way that I would probably do it. If you think of what that means, if you have excessive voltage drop here or here or here, what's that mean for your starter? Exactly. If you're dropping the voltage out there, that means your starter doesn't have enough voltage available to do its job well. Make sense? So if you have a voltage drop on the cable, but you put a new starter in, is it going to fix anything? The new starter still doesn't have the right voltage available to it, so no. So, right, that's why we're doing the voltage drop testing to tell what part's failing. Now, this is a good voltage drop test. If you do battery terminal, this would be like the big B terminal to the motor terminal. And while you're cranking it, you'd be, whoa, that was weird. If you do that test, that's really interesting. That display disconnected. That was totally crazy. Give me 1 second. Screen 2 is good. I have no idea why. Test, test, test. All right. Don't know why, but it freaked out, but we're back. Okay, looking good. I think it's okay. Yeah, we look okay. All right, so if we do this test, understand this is the battery, the B terminal to the M terminal. Does anybody know what we're voltage dropping right there? If you understand what I'm saying, we're talking about doing B to M. That would be these two. If you guys will remember, that'd be the B to the M. Remember the solenoid, how it could have that bad contact on the disc? If you want to test that, you can test that with voltage drop. Anywhere you think there's resistance, you can test it with voltage drop. And if the voltage drop is high, what's that tell you about the resistance? There's more resistance, exactly. So more resistance will cause less amps, and then you can do your voltage drop testing and determine where the excessive resistance is. That's pretty much the name of the game. Testing, not just replacing parts. No shotgunning. Cool. So we could voltage drop all this stuff. We could voltage drop the ignition switch. You think the car's got a bad ignition switch? Well, simple. Let's just voltage drop test it. What should we drop across the ignition switch? Maybe 0.1. I might give it 0.2. But if you're dropping 4 volts across an ignition switch, that switch is no good. Then you sell the ignition switch. Or if you're dropping excessive across a clutch start switch or a neutral safety switch, or right, all the parts that could be bad, we could voltage drop test those. Well, on this side, unfortunately, you have to have it in the crank position. You have to hold it in start for it to send voltage through all these. So you'd have to have it held in the start position while you voltage drop check things. If it was the B side, you could actually test this at any point. But to really do the best, most thorough test, it should be during cranking. And that's where it gets a little tricky. It's when diagnosing starter stuff, it's really helpful to have 2 people because you need to be worried about the key position. Cool. So anything you think on the circuit, you could voltage drop test it. Right. And same, this is showing the starter relay. Like starter relay testing is the same as any relay. You have to give 12 volts to 1 and ground to 2 so that this switch will close, and then you can voltage drop test 3 to 5. Or you could resistance test 3 to 5. But to test 3 to 5 where the contactor is, you have to actually power and ground the coil side. Right? And similar with the switch, if you wanted to test the neutral safety switch, you could check on ohms and you could put it in park or neutral and it should have very low resistance. But also there's an adjustment to be worried about. So if a car had a transmission put in and ever since then it won't start, it could actually be that this switch is out of adjustment. And when you're in park, it thinks it's in reverse. The car's not going to start. So be aware of some of these external factors too. And similar with the clutch, like if it's a clutch switch that's way out of adjustment, it may not start due to the adjustment. Cool. And then we won't really do too much with bench testing because that's what I was saying. This is more like what the parts store is going to do. This is all the stuff that they would do on the rebuild procedure, or they should do on the rebuild procedure. Although this one I made you, that's testing the one-way clutch. All right, so let's say you think it's the starter, but you also think it could be like if it's a reman starter, or let's just say that the starter had worn gear teeth, like we were talking about, had worn gear teeth or worn flywheel teeth. Some of the older starters needed to be shimmed, and I'm not even really very good at this. I find it to be somewhat of a waste of time. There were so many different starters that have been remanned so many times and so many different engines that they would actually sell shim kits. Has anybody ever seen shims? That's what those are for. So it may say like, with this starter, use this shim. Or if you put the starter in and it screams really loud, it might be not hitting the teeth right, and then you would shim it. But I won't spend a ton of time on that because this was like old school, like a small block Chevy. If the starter's screaming, it probably needs to be shimmed when it engages, like when you crank it. And there's a couple measurement processes, and that's what they're saying. The whir sound, that'll end up damaging the flex plate or the flywheel, which means then you got to pull the transmission. So I'm not saying that the shimming's not important. I'm just saying of everything, I don't want to spend a ton of time on the shimming. It's definitely old school. All right, what about hybrid? You like hybrids? You hate them. Do you know Some hybrids have starters, but a lot of hybrids don't. You ever heard of Prius starter motor? They don't have them. You just notice when you go to start a Prius, it just kind of goes, vroom. Well, I mean, like maybe not that mean, but more like, like definitely a lot less intimidating. It's because it has no starter. So they'll use like a motor generator. In the case of a Prius, it'd be MG1 does MG is motor generator. So if you want to start it, MG1 will function as a motor and it's directly connected to the engine and it'll just instantly start it up. Which means on a Prius, the little battery, the 12-volt battery like this, doesn't run the starter. It only powers up the electronics. So the Prius battery can be very small because it just needs to power up the electronics. And the big battery, like we talked about in the last one in batteries, that big battery will power MG1 and just fire it up instantly. So hybrids are totally different, but you still need to know a little bit about it because they're much more and more common. And then MG1 as a motor starts it. But then next week, when we cover charging systems, MG1 with the G as a generator charges the battery. So motor, generator. So it's almost like a starter and an alternator in one. It starts it and it also generates from it. It's motor and generator. It's pretty interesting, I think. Right? And so on some of them, though, they do have a regular starter. You can tell by the sounds. Right? So if we were to look, like, let's say this one. This right here is MG1. This right here is MG2. This one drives the wheels. And also when you're going downhill, it does regenerative braking, and that's when it's G generator. Right? So this drives the wheels and gets regenerative braking. This one drives the motor to start it and does generating like an alternator. Honda's is different. When we have this could be like IMA, those still need a starter, at least the older ones still need a starter because this really just drives the wheels, but they do have some that'll actually turn the crankshaft through like a flex plate type thing. And then you have this one that's a belt alternator starter. That would be like, let's say it was a Jeep Wrangler e-torque system. Those have a regular starter for the first time you start it. But then if it does the auto start stop, you guys like that function, right? Auto start stop. When it does auto start stop, it's like, we don't really need the starter. We will just power up this belt alternator starter, which is essentially like a mega big, huge alternator with a big old fat belt. And it can run like a generator, generating electricity to charge the 48-volt battery. But also on start stop, it can run as a motor and crank the engine really fast. If you ever hear a car that restarts silently without the starter, sha-na-na-na-na-na, it's some sort of hybrid system. It could be any one of these three. They really vary. And that's kind of what this is saying. We don't need the 12-volt battery on those hybrid systems. We can use the big battery. I gotta say, actually, that part's kind of nice. So if we're speaking of, the start stop, if it's a hybrid, all these technologies are, I think, superior. If it's a auto start stop, idle stop, they have different names. That is, if it's not a hybrid, we have to use the starter so many times, right? Like back in the day, you start it in the morning, you go to work, you shut it off, you start it leaving work, you go home, you shut it off. It maybe works 2 times. But if you have a long commute and it's doing start stop and this starter restarts it and restarts it and restarts it and restarts it, how long do you think that starter is going to last? Not as long. So they've made better starters with different, higher performance bearings and better contactors and better this. And they also on the start stop systems, a lot of times they have a starter counter. And once you hit a certain number of starts, it sets a code and prompts you to replace the starter as like a preventative maintenance. So love it or hate it, that's what you got. But it does technically save gas and it does technically lower emissions. And so now you guys remember, I've told you before, a lot of the driving force here isn't because the customers want start stop. It's because the government says, get this mile per gallon number, and they're figuring out how to do it, and they have it shut off at every stoplight and then overwork the starter. Like it. Got to have it. All right, good. So yeah, this is the starter draw testing. Like we talked about the results, but you can see the images of it being done. This is your amp clamp. So that one's 3.5 amps right now, but when we crank it, assuming we got it on the charger like we should, we're going to get a new number. Or ideally, if you can put it around the B wire that goes right to the starter, that way you're measuring only the electrons going to the starter. Whereas if you're back here, this one's at the positive. This is technically measuring everything that goes everywhere. So it might not be quite as exact to do it this way. But if you know where the starter is, sometimes they're hard to get to. So this is better. If you can do this, do it. But if you can't get to it, we can probably do this and it'll be pretty approximate. Like even if your headlights and stuff are on, headlights, taillights, some modules and whatnot, those might draw, 20, 30 amps. The starter is going to draw like 200. So we should still be able to mostly get a good number, right? But it's got to be on the charger. There's a couple ways that you can do it. You can crank it with the key, or sometimes we'll actually disconnect this and use a remote switch, which that's kind of old school. So that's the general rule. When we do the lab, this is a page you're going to see. 4-cylinder engines, 150 to 185, 6-cylinder, 160 to 200, 8-cylinder, 185 to 250. And that depends on some details like how high the compression is and what size of a V8 it is and whatnot. But when we go to do this test, you're going to actually record how many amps and then interpret whether it's good or bad. If the car starts normally like a lab car, it's probably going to be in spec. But if it was like that Tundra, and it reads really high, now you're looking for a mechanical problem. If it reads really low and it cranks really slow, you're looking for more like high resistance, corrosion in the circuit or something. Kind of make sense? So this is just a shot of the lab that we're going to do. Cool, so it'll be fun. And voltage drops, like we talked about them a little bit already, but just keep in mind, we should have almost no voltage drop on all these circuits. We should have almost all the voltage drop in the starter itself, like as discussed. And the way that I would do it would be slightly different. So if I were to go and do this test, I would probably consider doing it slightly different. You know how we voltage drop the wire, where we, like right now, we're voltage dropping the solenoid. A lot of times what I'll do is I'll just do available voltage and I'll calculate voltage drop in my mind, just like what we did in the earlier worksheets. If I wanted to test this solenoid contactor, I could voltage drop it directly, or I could hang my black lead on the negative terminal and I could take my red lead and check battery voltage. If it's 12.6, if it's 12.6 going into the switch, what should it be coming out of the switch in the crank position? Maybe 12.6, maybe 12.5. But if it's 6.2, I know that I just dropped like 6.4 volts. I can't have a 6.4 volt drop through the switch, right? So you could voltage drop this with your short T-Rex arms and check individual things. Or like just my personal preference, doesn't have to be yours, is I can check available voltage going down the line, and I can run rough calculations in my mind like that was too much of a drop, right? Makes sense? Either way, available voltage or voltage drop. Mm-hmm. Mm-hmm. Sure. You are. This is in your lab. Um, Correct, but yes, you are going to use the clamp. The reason we can't open the circuit on this is because if this starter is going to draw over 100 amps, your meter is not going to go for that deal. That fuse is not going to be blown. That fuse is going to be like, so when you're testing a starter, you're exactly right. When we're testing amps in a smaller amp circuit, open it and put it in line. Yes. But when we're testing a starter, we need to get the amp clamp, and you need to do it inductively because there's so many amps, your meter is not even remotely in the realm of being able to handle all those. So it's more going to measure the magnetic field and interpret the magnetic field and give us a number of amps as a result of the strength of the magnetic field. It's not actually interrupting it, it's just measuring through inductance. That's why that clamp we showed, this is an inductive clamp. None of those electrons are even going in there, really. It's inducing a magnetic field, which is inducing an electricity, which it can then show as a number of amps, even though it's not directly measuring it, if that makes sense. Yeah. Yeah, I get you. So, no, I understand exactly what you're saying. So we can do some voltage testing and stuff, but if you're going to actually do amp draw, no, you're on the clamp. This is a good way to do voltage drop. We could do voltage drop testing as well, but yeah, don't even try to measure amps on a starter without doing the inductive clamp. Please. Cool. So generally this is what we're going to do. So like this one, for example, if you were to want to measure the amp draw, technically right here would be good. Or, and this is the motor terminal though, so that's just this little wire right there. That's going to be tough to get to. So probably what we'll go is to like the B terminal, which would be, this would be your big battery cable. Probably do it there. But technically, if we did it right up here by the battery, do you see the amps going this way are also going this way? So we're getting a little bit of an abnormally high reading if we do it here, but that's okay as long as you kind of compensate for that, because sometimes it's impossible to get all the way right down to the starter. So you just got to be aware. Yeah, this is the big cable. Yep. And then this was a good example of a starting system diagram that you may see, on ASE. So this is really the same as what we've already covered. It's just a different style. So if you look at this one, it's pretty much the same. If you break it down, you're going to be like, oh, let's see, we have 12 volts coming out of here, going here, and then that's it. We have 12 volts going here, here. If you have your neutral safety, notice this PRNDL, that's your Prindle, that's your neutral safety. Let's say we're in park, it's connected, goes here, boom. Then if we look at the ground side, we got ground coming up. If we have power and ground to that relay, we get magnetism. That's going to close this contactor. So imagine that one's closed. And then let's say, what did we have from here? It went off over. Let's see. How did the power get to there? Oh, I missed this. Here we go. This power came over here. The contactor's closed, right? So now it continues. And it makes it all the way to the S, right? And then if we've got ground here, and then this is going to be, now that this gets powered, it's going to magnetize that coil. Then because your S terminal has power and this is magnetized, it's going to lift that disc, which means big B is going to go over to big M and run the motor, right? So it's just the same diagram. They could show it 1,000 ways, but the concept is still the same. All right, and then you can see the chassis is still the way that the ground has continuity, right? Nothing real new. And you should be able to do, the reason we've traced it so many times is if you're going to do voltage testing, you got to be able to trace it and then interpret where the voltage should be and what it should be. Cool, so this one's pretty similar, right? Looks different, but is it really? If you look, it leaves the battery in the positive, goes to the fusible link, but it also goes to the big B. If it goes to the ignition switch and you turn it on, that's going to send it over the neutral start or the clutch switch. And if your clutch pedal's down or you're in park or neutral, it's going to send it over here to the relay. The relay is also going to have a ground. Oh, that was the ground. Yep. So this is sending ground. Got that. We could trace that one. That one was a little bit more complicated than I thought. Red goes to here. Red goes to here. Red also goes to here and here. However, the ground goes over to the battery in a roundabout way. Then what's happening right here, I would say that ignition switch is probably going to send a positive. No, it couldn't be a positive. It would actually have to send a ground, which is a little bit weird. That's okay. We can do that. If the ignition switch is working, it sends a ground, which is going to send this. If that's grounded, this magnetizes, which then means positive goes through the starter relay and to the S. And if it gets S, that's going to close and that's going to send big power to M, right? It's the same. All makes, all models, all manufacturers have various different versions of the same thing. Same with this one. If you look, this one's the same. This ignition switch is going to power the relay. The neutral safety switch is going to ground the relay. If you have it in start and in neutral, this will get 12 volts in ground, magnetize it, and big power will make it to the S terminal. The same. Cool. So if you were to try to voltage drop this, let's just say we had let's say that you put your meter lead, let's go with, you put your meter lead here and you got 12. And let's see, you did available voltage again and you put your meter lead here and you got 0 volts. What's happening there? It stopped right there, which means the switch is open. And then you're like, oh, whoops, I forgot. I needed to put it in start. When you put it in start, let's say your 0 becomes a 6. We're dropping 6 volts through the switch. Is that good? Switch is bad, right? Again, it's the same. You learned these lessons. We're just applying them to the starting system. Cool. And I think with that, you should pretty much know what you got, right? And that's what this is. That's really what all this is showing. It's just giving you the visual of how to test the relay, which we did once, and how to test switches, which we did. Now, when we go to redo a starter, that's what this is showing. It's very simple. First step, disconnect the negative terminal and make sure the negative terminal can't be reconnected. Then when you go to do this starter, if you look, there's a big terminal, that's the B wire. There's the S terminal, that's the small wire. You take those two off and you unbolt the starter, and next thing you know, however you get the starter out, it's out. It's not, you're going to do that next lab. It's going to be very easy, right? I think you all can do that. So you will be R&R in a starter in lab. Now this would be, I believe this is my picture. This is that Tundra 2UZ. So you don't see the starter because you got to take all this intake and fuel rails and all this stuff off. And then you realize, oh, there it is. It's down there. So the starter is simple, but that doesn't mean it's easy, right? North Stars have it under the intake. Some other vehicles have it hidden in other spots, which makes me a little frustrated, but it's all right. And then this one, when we were talking about the starter draw, just that's another thing. So you're going to R&R it, but you're also going to do a starter draw test. But also, this image was more for the second page. This has you doing some voltage testing. So you just remember what I said about the voltage test. We're going to do those as well. When we're doing a voltage test, generally we want to do it while it's cranking. And then the last point I have is when we're talking about starting systems on the newer cars, you just have to understand it blends into some more advanced concepts like security, immobilizer, various types of immobilizer stuff. So on some cars, if you go to start it and you don't have the correct key, it may not crank. And then you're out there checking, you're like, I've got no voltage to the S terminal, and you're checking the relay, and you're checking the fuse, and you're checking the ignition switch, and you're checking all that stuff. When come to find out, if it's computer controlled, the ECM won't send power or it won't provide ground because you don't have the right key. And then if that's the case, it's probably going to have a light like this, like this, like this, like this. So maybe the first thing to do, if it's a newer car, jump in and go to crank it and look and see if any weird lights come up on the dash. And if it's giving you a light that looks like these, it sounds more like that's an immobilizer or security issue. Kind of makes sense? So don't start voltage dropping a bunch of crap. Be like, what's up with this key? Then you look and the key looks like it's brand new or something. They might have got a key cut, but they didn't program the vehicle to accept the new key. That's pretty typical. And then let's say that you get into push button stuff. With push button in a way is more secure and less secure at the same time. If it's a key, this will probably lock the steering column and also make it not start. Whereas if it's a push button, a lot of times it's looking for the key before it'll power on modules, but a lot of times it won't lock the steering column, so they're not necessarily more secure. This was mostly made for customer convenience. Like, you don't have to take the key out of your pocket, put it in, and turn it. You can just put the key in your purse and get in the car and just push the button. You don't have to, there's less risky to lose the key. So this is generally for convenience, and I think it's mostly a good thing. The negative is when we go to test this system, it's way different. There's no ignition switch. So in all those diagrams with the ignition switch, that's not really there. We have a start-stop switch, and the start-stop switch is an input to, like, sometimes what we have on here, like a smart key module. And so if you wanted to test that ignition switch or that push button, probably not going to use your meter. You're probably going to go to the scan tool. You're going to go to the module that monitors that. So if this ignition push button sends a signal to, let's say, the smart key module, you're going to go in with the scan tool, you're going to look at the smart key module, and you can see if the button's pressed or not on live data, like a PID. You can see it on or off, right? So if it's a no crank, no start on a push button vehicle, some of it's the same, but some of it's different. So if I were to roll up to it and it was a no crank, no start, and I listen to the starter, and when they try to start it, I hear like it clicking and doing something, that kind of tells me, hey, it's getting a signal and it's trying to do something. So I'm not worried about the key and the immobilizer and the smart key and all that type of crap. I'm worried more like, does this have the right voltage? So then I'm back to diagnosing normally. Or it could be that battery that's low, right? Like the one that burned me in the beginning. If it's a low battery and you waste 2 hours trying to learn about the smart key, it's going to be really hard to justify getting paid for that. Whereas if I roll up to the car and I hear nothing out of the starter, and then I go to the relay and I feel nothing out of the relay, I'm like, doesn't even seem like the module's trying to command the relay on to run the starter. That's when I might start looking for codes, looking for diagnostic trouble codes, jump in the scan tool, check, because a lot of these immobilizer things, they'll set codes, unprogrammed key or whatnot. Or if you had a failure of the fob, or if you had a failure of the sensor, or if you had a failure of the switch, that's all scan tool diagnosis, just so you know. It's not going to be old school. Like, we can be really thorough about voltage drop. We can be really thorough about starter draw. Those are universal concepts that still apply. But if it's a newer car, scan tool, codes, live data, in addition to all the old school tests. Kind of makes sense. So this would be hard to teach as part of this class because it's very manufacturer specific. The general rule of thumb is when you get in with the fob, there's going to be a module that's looking for the fob. And it's going to say, oh, I see a remote. Is that the remote that's programmed to my car? Or am I authorized to recognize that remote? If no, guess what? The doors won't open. Nothing's going to work. But if the door is on lock and stuff like that, trust me, that remote is going to be, the vehicle's been programmed to recognize that remote. You don't exactly program the remote. You program the car to recognize the remote, right? And if it's able to do that, you know the remote's programmed. However, it gets a little more complicated. That module that sees the remote then has to send a signal to another module to say, yes, you're permitted to let this vehicle start. And if you have an error in that communication line, it won't start. And then you're diagnosing the error between this computer and this computer, and that's networking, and that's all electrical too. We're not doing that here. Generally, no. But some stuff you do. We might not have it directly from the manufacturer, but all data has some of that. It's just, if you have to program a new key or like program the car to recognize the fob because you got a new remote, with unlock and lock doors, yes, but with starting the car, probably not. Like one manufacturer, I had to log in and I could get half the Kia. I had to log in, I get half the code. If I wanted the other half of the code, I had to call and talk with a human, and the human had to talk with me for a bit and know who I was and then give me the other half of the code. And I had to put them both in together. So like some of this stuff is really like on lockdown. Now that was on the Kia, I believe it was the Amante, which was a while ago. Then Kia got really loose with it and they're just like, yeah, anybody can program. And then you saw all those cars get stolen. So Camaros right now are being stolen daily because all you need is the scan tool to go in and you just say, all the remotes lost, clear everything, program a new remote. So they'll literally show up, they'll fake it out, like just make one connection to power it on so you can communicate with the modules, plug in the scan tool, clear all the old remotes, put it in relearn mode, learn the new remote that they brought brand new from the dealership. And now that's the only key to that car. They start up, drive it off. They can do it like in under 3 minutes. So they can steal Camaro in 3 minutes. Not mine, because there's multiple layers of security and other preventative measures along the way. But yes, if you had a Camaro parked out in the lot, they could have it gone in 3 minutes.
You have to buy that first one from the dealer. You can't get it from other sources.
Technically, you could, yeah. If you found one, if you found an aftermarket and you could get it, yeah, you could. A lot of times they can sell the fobs, but a lot of times the full smart key, not a lot of aftermarket companies make those, but maybe. So this is where it gets a little tricky, right? And this is why the better designed systems are complicated, because if it's complicated to steal, that makes it kind of complicated to fix. So this part of the job changes and you're more in the computers and checking codes and checking for communications and checking this thing and checking that thing. And so that part, I'm going to say, let's save it for another time. That's all you're going to get with the with starter diagnosis, right? And that is actually where we're going to end. So you guys did good.